Hello, good morning to everyone. Hello, good morning to everyone. Can we start the class? Can we start the class? Okay.
Yes, ma'am.
All the symbols. First, I'll start with the symbols and cross section of the walls, everything. Then we go for the practical thing. Today's class will be too important because until unless so the controls, that is nothing but walls. You cannot work on the system. If the power source is there, or if you go have to the other side application, that is all secondary. But first identification of your working circuit is very, very important. For working circuit, you have to identify the walls and its connections with the what is the design of this and how we are going for this taking applications. In your working circuit, there may be a different type of walls will be there. For example, if you start with any directional control walls, maximum of the circuit contains direction control valves. In the short form, you call it as a DC valves. Then one or two places where you want to control the speed of the pistons or any movement of the machine, there will be having the check valves or flow control valves, or only one side means you can have to throttle according to your applications. But by looking all those things, it's very important for us to start with the whatever the very much needed for us that we have to understand. Today's class, please, just it is I think all the setup is will be cooperating with us. So you also please concentrate and we'll start most of the things. Okay. I'll share the things PPT. Actually, when we wanted to say for the construction and symbols or working functions of the symbols of this was, commonly we are imagining that hydraulics and pneumatics is same almost all the symbols. So what I made is, today you are in the hydraulics or pneumatic application, it is better to understand both this type of the small differences. Only the difference is only one. Wherever you are going for media working is oil in the case of hydraulics, compressed air in the case of pneumatics. But nothing is different in the symbols. Everything is same. Only instead of the tank circuit, tank port, you have to connect an exhaust port. Only two things you have to understand. Now in hydraulics things, you have to see that source and exhaust ports. Source will be the oil and exhaust will be the closed. Because of the closed loop, the oil will be circulating into the tank. But in pneumatics, the source is my compressed air and we are not having the this thing closed loop system. We are having open loop system. Every time the air will be exhausted to the atmosphere. This is the only difference. Symbols, everything is same compared to the all the pneumatic or hydraulics. Some of the differences, wherever it comes, I'll mention the differences. Where is the mentions, you have to see the concentrate. Today's class, I am taking a common for both hydraulics and pneumatic symbols. Wherever the difference comes in here, I will mention that. Because after afternoon classes, I am starting with the solenoid valves also. So, this is a continuation class with the symbols, identifications, numbering, letter-wise, everything is nothing but same pneumatic and hydraulics, somewhat same. So now we'll go for here. When we go here, we can see that so here you can see here in hydraulic system, the hydraulic system can be divided into the following sections: the signal of control signals and power sections. Now you will be having a signal control section and power control sections. So you have to identify that how signals are controlled and power sections is how it is controlled. Now next here you can see that signal control section and power control section. Signals from the input. Signal from the input means maybe push buttons, or you may be different type of toggle switches, or you can go for the different type of sensors. All the inputs are categorized under the signals. All the inputs. Outputs, for example, output you can consider an actuator, or piston, or cylinder, or motor, or a relay, or a solenoid. Solenoid means also a valve. Different type of outputs and inputs are concentrated here. Now, for example, we have to differentiate here. What are the different type of actuation of the signals and how the signals will be processed by the operator or by pneumatically or mechanically or hydraulically. The valves we are having, how we are controlling. For example, I am the person, how you give me intimation for calling. If I am very fast, you are touching me and you are calling. If I am very far, then you will give a signal so that I can see, or you can wave the hand, or you can call me, or like that. Any different when the signals are operated by nearby, we cannot imagine for automation. Automation means the signals will be controlled from the outside. The signals is processed through the machine side, and totally we are without any things or without any more number of sensors we are processing for a say automation. Like that, we cannot imagine it's not like a punching machine. Every time the operator will be punching. It's not like that. We have to go for continuous cycle. Once the signal given, the memory valve will be having. We call. I'll come back to that again. Some will be calling a 5/2 valve is a memory valve that keeps in the memory condition. It's keep on punching. After the signal, when we give the stop, it will go to the end of the process. Like that, we have to imagine what is the different type of actuation for the valves. Second, how many different type of actuations are coming? Whether it is a single stage or it is multi-stage, or how going for the cascading of the signals. That is called as a cascading of the signals. For example, if you go for this, now here I am showing here manually operated, mechanically operated, both are nearby. It is actually we are going for the contact. If the contactless signals are given, it may be by pneumatically or hydraulically or by the sensors or without solenoid ones. Like that we are going for the signal processing. Next, when we go for this power control, the power control supplied by the drive section by the power control sections is according to the control system. The following components are performed in this task: direction control valves. We are according to the function of the valves, we are divided into 5 sectors. Okay, one is purely, that is maximum number of, in a circuit, if I take a hydraulic and pneumatic circuit, maximum number of valves are DC valves or direction control valves. Next, second one, on the flow we divided, that is called as a flow control valves. On the pressure we controlled, it is on the pressure control valves, pressure control valve, pressure relief valve, pressure sequence valve, different type of pressure functions. Fourth one, when we go for, I want only one side of flow, other side should not return back the oil. That time we go for the non-return ones. It is only one way one. And second, sometimes, for example, I'm having punching machine. It should punch and it stay in the on condition for 5 seconds. Then the piston has to return back. There should be a delay in that operation. That time we go for the time control ones. Like this, 5 division or 6 division, we are going for the function of the functions. Okay, is it clear? No, the valves are classified on their function, on their design, methods of actuation. The valves are divided into 3 functions. Functions are divided like design, methods of actuations and functions. On the category wise, we are dividing now. How we divide this? Today, I am taking the class on the PPTs, but actually, until unless I'll show practical, you will not understand. I'm showing on the board also, I'm showing some animations. Simultaneously, we are going for the practicals. So today, please, I'm requesting you all, please be attentive. If you are getting little bored, you can ask me. That time I play the some videos. And today we are actuating with the simulation software. So yesterday I have sent you some material. In that we have fluid sim, P and H. P stand for pneumatics, H stand for hydraulics. Simulation software also I have sent. Some of the videos I have sent. And today also I am given some Norgen training folder. Have you seen that Norgen training folder? In that actuator, walls, and identification of symbols, everything we are given. Today I am explaining everything. When I am explaining some topic, please, I request you to open that in your things, PCs or your phones, and simultaneously you have to check. That time you will get some ideas. Then you have to share with us. After sharing only, my knowledge also increases, your knowledge also increases. It is a two-way. You have to interact, then only we can understand what is in your minds is going on. I request once again, please attend this class. Whatever yesterday has happened is yesterday over. Today we'll start with the very good classes. It may extend for some more time. With your permission, I can extend for some more half an hour because tomorrow my guest faculty is coming. He is taking some other topics. I cannot tell him to change now. We already scheduled. So that's why today almost all we are in the afternoon session. After 3 o'clock, I'll continuously doing practical. So that time maybe you are interesting. So that time please up to it may extend some 5:30 or 6 o'clock. We'll take a small breaks and we'll see that and then we'll continue the class. But today we have to finish all this portion. Whatever yesterday we are lagging out. Okay. So this is the one I'm telling the walls are designed in based on the function, design and methods of actuation. Now, there are different types of walls I've shown. For example, here some of the walls is shown on the non-return walls, directional walls, pressure control walls and flow controls. Look, it looks like this, but it may not similar to your industry side also. It may not similar with the trainer kit also. A different manufacturer, different gives the shape and the actuations. So, but some are other way, we have to see that one. The wall design, now when we go for the wall design, it is based on this spool function. Yesterday in whatever the video we are playing, they were discussing puppet walls and spool operation walls. There are three type of function in the inside the things. One is disc operated walls, one is ball operated wall, one is spool operated wall. But disc operated wall and ball operated wall are called as a puppet walls. Okay, but here it is having some small disadvantages. Disc and spool operated wall constructionally little bit more costlier and there will be chances of leakage. Okay, when we go for the high pressures. But spool operated wall is very good in thing. Constructional cost also decreases and also we can go for the good ceilings also. Like spool principles and puppet principles, some of the spool principles are maybe having some flow leakage, but puppet walls are good ceilings. Sensitive to dirt and here non-sensitive. So we are sometimes we have to see the pressure level function, then we have to go for the type of things. Okay, a simple construction, spool is very simple construction, even in the case of multi-position walls, but here complicated will start from after some complication and position of multi-purposes, this will be giving some problem. So pressure is compensated, pressure compensation must be achieved. Here we have to see that puppet walls or disc operated walls, we have to see that it should be achieved. Now, long actuation strokes, short actuation stroke. So that's why how we distributed this type of things. Starting sensors. For example, starting sensor, all is my puppet walls or disc operated wall. Next, second stage walls, that is my actuation start from the pneumatic control and hydraulic control, indirect working. For example, I start a sensor here with a disc or puppet walls. That signal goes for the processing session. Next wall, that is my spool operated. That's why we have to see that all the start sensors are wherever I have this small walls, which is having 2x2 wall, 3x2, that type of walls all constructed with the puppet and disc. Then next, when we go for the processor, I told you, 5x2 is called as a memory wall. That memory wall with a 2 position, 3 position, 4x2, 5x2 walls, all are spool operated wall. Like that we distributed on the function also. After that, when we went for Here next. For example, an operator is the mechanism that causes a value to the wall to change the state. They are classified as the three things. For example, manually you are operating. For example, you cannot operate all the walls with a very far distances. For the safety purpose in the industry, sometimes start sensors are is always with the push buttons. It may be emergency stop, or it may be switch, or a toggle switch, or key operated wall, or plunger type, or limit switch, or you have another different type. So it is different. We having push buttons, sprouted button, mushroom button, twisted button, switch type of like emergency stop, key released, key operated, plunger type, roller. All are called as a manually or mechanically. Sometimes we are going for the solenoid walls with the release valve. The first, if you go for this, we have go for the things. Okay. Is it any problem? All of you? Hello?
No, ma'am.
Yes, sir. What is any problem, sir, with audio and video?
No, ma'am. Everything is fine.
No, ma'am.
Okay. Then I'll continue. So now when we go for this, you can see here some of the things I told you, different types of manually operated one. For example, in the industry, whatever the function with respect to function, maximum care is taken for the safety also. For that, emergency stops will be there at in between the things. There we have to go on emergency press. That time it should be manual only. Sometimes until unless I will not release the key, somebody will come and just push that. For safety purpose, they will keep the key also. For example, you can see that this type of thing is key released or key operated ones. Sometimes plunger or limit switches or roller type. Have you seen the roller type in your industries? Roller type is a mechanical type. It is giving other actuations. One-way tip wall, like this somewhat small plungers will be there. One-way tip wall that I will show. This type of wall is called as we call it as a ideally written wall. I will give this explanation when it comes for the cross section. When the cross section of walls I am showing, that time once again I will take the roller operated and one-way roller operated. I have both the thing. I will show operating with the actuation. So air piloted means pneumatic wall. Sometimes with the piloted. I will tell you what is the meaning of piloted walls. I will tell you that also. Solenoid piloted wall. When I take in detail after this cross sections, I will go for the piloted walls and how the solenoid walls also piloted. What is the advantages of because of this? Constructional cost. We have to see all the things. Once after its functioning, we have to go for the better design where we can go with the small signals. It means there we have to give the force. Force comes in picture. Whenever we are not getting more force to operate the things, we have to go indirect method. That type also is called as a piloted walls. And how solenoid walls construction and cost of that coil has to reduce. That is, we comes under the applications of solenoid walls with the piloted walls. What is the amendment for that? I will go in detail. So these are some of the things which is actuations. Manually you are operating. Now coming for the next, symbols. The symbols and non-written walls, I will come in the detail after first I will take the direction control wall. Then second I will go on the flow. Third I will go on the pressure. Fourth one I will go with the timer. Now after this thing, I will go in detail of this. What are the different type of non-written walls, everything. What is meant by check wall? Before this, I will go some of the symbolical representation of the lines. Okay, the representation of the lines. Okay. Now, when we see go for this hydraulic symbols, now here I have to see that I told you some of the lines we have to see in the hydraulics. The symbols are common, but when I have to see the things which we go for this, this is the one. We have to go for the symbols with the lines. Now, when we go for the lines, there may be a thick lines or there may be continuous lines, long dashed lines, short dashed lines, and double or long chain thin option. Like this lines will be there. All are considered as now, for example, all these are called flow lines. Now, this is for this mechanical connection with the shaft or rod. And the third one will go for these enclosures, and the several we are going for some enclosures we are giving. This is the one we have to consider in the drawings of your industry circuits. These are comes in picture when some drawings is given to you. You have to see the drawings and you have to work out. That time we go for this type of walls. Circles. For examples, wherever you go for this type of circles, small semicircles are like this. As per the rule, we have to see that big circles are considered for the energy conservation, like a compressor, motors, that is energy supply, power supply. Small, little bit small are is explained with the measuring instruments. Small non-return lines are roller limited. Small lines will be there. I will show in the cross section. So today's class, it is how means I'm showing with a big tree with a small branches. If you see the branch, you will not understand where it is connected. Once after 1 hour, you can understand that how I am relating that all the different type of walls into the hydraulic and pneumatic section. So you please have some patience. I will explain one by one so that after writing here, I will go to the board and I will actuate with the hand. Similarly, then later I will go for the simulation. So by seeing the symbols, now you will be having some more, it's not clear. After 1 hour, you will come to know what is the structure for this. So small, like for example, measuring units, maybe a pressure gauge, or you are having our pressure switches, or you will be having some meter. Sometimes when I want to check with the proximity sensor, I may keep a ammeter or voltmeter or multimeter. Like that, we have to indicate that is a measuring units. Small return lines, that is non-return links, roller type, will be having that circle also. Next, we'll be having some mechanical link. There also will show a small circle. Semi-rotary actuator. Yesterday I showed with a semi-rotary actuator that will be actuating with a thing. That actuator also denoted by the like semi circle. Dash L shows the length of the dash, E shows the thickness of the line, and D shows the space between the lines. Now next, when I go for this, I will show always whatever the symbols of the hydraulic or pneumatic wall symbols is represented by the rectangular boxes. If I show with a single rectangular boxes, then it is having one position. If I show the two square boxes nearby like this, if I show this, that wall contains two positions. If I show the same thing with the three, then that wall is three positions. Or if I show the four or five boxes, then you should think the position 5. What is meant by position? For example, I am going for near a tap. The tap, it is closed. You are going to open. The tap has two positions. One is on and one is off. Then I should represent that valve. What is opening and closing is with the two positions and two lines. That two lines means output line and input lines. Like that I have to show with the ports and position. Please remember all the rectangular boxes which I am representing on the symbols, that if I write one rectangular boxes, then it represents one position. And if I represent two boxes, it is having two positions. 3 means 3 on and off, but sometimes due to the circulation of the oil inside the circuit, it takes a neutral point. You cannot change it as fast as in pneumatics. You can change off and on and off. You have to go for a neutral position, then it has to come back again in the on position. That pause or neutral, that comes in between that 3 position ones. So that is 3 position. For example, you have 4 position, 5 position ones. For example, my 4-wheeler. I am having 5 gear. I think you are understanding. First gear, second gear, third gear, back gear. Then I am having so many different functions in each gear. My speed level is changing. That's why I have 5 to 6 position in that 4-wheeler. I hope you are understanding the position. What is meant by position? Position means in one position, some function is going on in that wall. Second position, it may go to the different position and it takes some other function. It goes to another position. You cannot simultaneously, you can keep on changing as fast as possible. For example, in hydraulic system, because of the oil has different viscosities and heavy load, it takes time to circulate the oil inside the circuit, through the wall, through the walls, to the tank, from again to the supply. Again, it has to take the closed loop system. That times it delays. The delay is represented in the wall with a neutral position. For example, in pneumatics, the air is coming. I'm having 2 position wall. Suddenly my air is exhausting outside. Suddenly it changes. That time we don't need to neutral position. I hope you are understanding. For example, small functions. I told you, application wise, pneumatics has drilling, punching, pushing, like that small jobs. Okay, that type of jobs is with a pneumatic control, and we are every wall having exhaust port. The air is exhausted outside, so there is whenever the air exhausts outside, the piston movement increases. Wall function will be increases. That time they does not need any neutral position. With a 2 position only, on and off it will work. For the hydraulics, for the heavy loads, for different viscosities, we have to go for the different position of the walls, so that sudden change in the function of the any machine or JCB or anything, it cannot go switch on so fast. So it takes a neutral position. It takes a pause in the function. Slowly it changes to the another conditions of the working. So that type you have to go for the 2 to 3 position. Now I am explaining the direction control. My main intention is now I concentrated towards the direction control wall, which is the maximum number in a circuit. There also we have to say that, I think you have heard 2 by 2 wall, 3 by 2 wall, 4 by 2, 4 by 3, 4 by 5 by 3, like that you are heard that. Then now you are having in your mind, what is that 5 and 3? 5 by 3, 4 by 3, 4 by 2. What is that 4 and 3 represents what? That I am going to explain now. So now my concentrating towards the direction control. For example, similarly, apart from rectangular boxes, if I show a rhombus type, that represents a, for example, filters, separators, lubricators, heat exchangers, or if in the rhombus type, if I write a cross line like this and I show like a switch, it may be proximity sensors also. See, all this rhombus type things which will be having its own function. Some of these are symbols which is universally accepted with the ISO standards. So you have to follow this thing. For example, if I say, if in electronics you have color codes to read the resistors. Why the color codes is accepted? Because everywhere you have to see the colors, you have to see the color rings of the 2 rings, 3 rings, 4th ring. In that first ring, what represents second ring, third ring, 4th ring is tolerance. Like that we'll be having color codes. By seeing the color codes, you will understand the value of that resistance, whether it is ohms or kilo ohms or mega ohms, or with the tolerance, with the gold or silver, with the 10% or 15%. Like that we'll be having some theory. Like that also, here also according to the ISO, you have to accept some standards. According to the standards, that same standards will follow, but only small change in the shapes, that is depending upon the manufacturer. Almost. Now we are giving a concept in detail that how you are identifying the wall without anybody's explanation or anybody's representation on the stickers. Whether it's stickers, whether it is a noted sheet or stickers is not there, everything is gone in the industry. So many setup of the industries last 20 years. there is nobody is there to explain about you the walls, that you can understand by like this. That is universally accepted. And 90% of after this course, you are able to identify. First, our motive, that is our motto of this course is first identification of the parts, connection of the parts of the circuit, working condition. That is my main thing. Theory, it is already set up. Theory you can also refer by the catalog books or manual books. Other things, now without anything, how to become independent by identification. When a rhombus is there, you have to understand that conditioning apparatus is a filter, separator, lubricator, heat exchangers, or maybe inside that whatever the content is there, depending upon the proximity sensors also. It may same represent for proximity sensors also. Proximity sensors comes in electrohydraulics and electropneumatics. Okay. Now next, if I consider here, if I write like this, a small direction D, then it may be represented that it may be a line, flow line connection. If I show like this, there is a spring connection. If I show a small variation in this area, then maybe this is a restriction. It is affected by viscosity or unaffected by, it goes in detail. It goes in detail. Okay. Now next, if I show a triangular with a solid lines in outline only like this, if I show a dark line, wherever I darken the portion, whether it is a rectangular box with a darkened portion, it represents the hydraulics. Please remember, if I show a rectangular box, triangular box with the open like white color or it is not filled, then you should understand that is pneumatic one. Okay, I'll repeat once again. A rectangular box with the filled dark colors, that is black color, it represents the hydraulic. And rectangular one without filling the things color, or it is like white color, if it is there, then you should think that pneumatic flow. It may be a input or it may be exhaust. That will come later. Now, for example, an arrow mark will be there, like these lines will be there, that will show the directions. If I show the same lines in a little bit thing with the arrows like that, then the direction of rotation. The next I will go for some types like this, and whatever the thing, this will be comes in when you go for this, it will be seen in the when the walls comes inside. Path and direction of the flow lines through the walls. If I show a slash line, indication of the possibility of regulation or the progress is variable. Something variables you want to show, will show a things. Now, if I go for again further, the pumps and compressors, whatever the pumps and compressors are called as a energy suppliers. Correct na? Energy or source suppliers. That will be shown by the like this arrow marks. Okay. Fixed capacity hydraulic pump with the 2 directional flow. These are the one. Okay. Now variable displacement hydraulic pump. It's shown by the symbol like this. With 2 directional flow. It has a 2 rectangular like so variable. They are variable. Like this something which when arrow mark. Wherever then arrow mark comes, it is called as a variable. If I not showing any arrow mark on the above, then it is called as a fixed one. Now, here we can show some of the symbols here parallelly. Yes, see, fixed capacity compressor always in one direction flow. This is the symbol for the compressor where arrow is not, that rectangular box is not filled and no arrow mark on the above like this. Arrow mark is not in there. It is not a fixed. If variable means you will be having an arrow mark on this thing. Like this, we can go for symbols.
Excuse me, ma'am.
Yes, sir. Yes, sir.
Ma'am, I have a question. Ma'am, why do we use only gear pumps in fluid systems?
Gear pumps, huh? Okay, okay. Sir, depending upon the application, sir, this is. Depending upon the applications, wherever we are see, in industry, always we see that cost, maintenance, and space is whatever the space required for this. For everything, in some reasons, when I take the pump, no, sir, that time I'll go with the details. In details, where which pumps are used, what is the purpose of things. I will keep a note in this. Whatever your question asked, very good. You asked some questions on the pump. I will take that in the next class when I'll take for the pumps. Tomorrow's, I think, topic is pump. Correct, na?
Okay, ma'am. Okay, thank you, ma'am.
Okay, ma. Thank you, ma. Thank you. Okay. Then we'll go for this here. Keep a note. Gear pump. Okay. Now next I'll go for this type of. Okay. Now next, when we go for this variable displacement hydraulic motors, then we go for like displacement. You know, positive displacement and this one also, fixed displacement and pneumatic things. This will go in the detail. This is the symbols. I'm just showing the symbols. When we take this more detail in the different type of pumps and different type of motors, we'll go like this in detail of this. Now I'm showing the only symbols. Now we'll be having here variable displacement motors, fixed displacement pneumatic motors, and variable displacement hydraulic motors, oscillating motors. All are, you can see here in clear, wherever that it is filled, it is meant for hydraulics. If it is not filled, then we go for the pneumatics. Now here, fixed displacement motors or pumps will be having the direction like this. And also here you can see here, some of the symbols also, we can see that some with the universally numbered, that numbers also there. For example, in pneumatics, ISO 5599, all the walls are donated. For ISO 55119, that is represented by the energy flows. Like that, the ISO gives the number also. According to that, we have to go for numbering. That is also I will explain you later. So these are the cylinders. For example, I told you yesterday, the symbols with only one port, the piston is there, then it is returned by an unspecified force. Maybe it is manually overriding, like that type. Or it is returned by the spring, you press it, the cylinder moves with the hydraulic power or pneumatic power, it comes back, but mechanically, that is by spring loaded. That type of things, how we are represented with the spring and without spring. Now, if I go for double acting things, then we'll be having a double lines, okay? With a single line piston rod, we'll be having like this. So if I have a double-ended piston rod, I will show like this, okay? No, differential, any cylinder is there, differential, some design you are changing, differentially should go for these different positions. The action is dependent on the difference between the effective areas on each side of the piston. This goes in the in detail. If we go, it will show the what is the inside displacement that will go for the differential cylinders. For example, I'm having variable cushioning. Yesterday I showed you single fixed cushioning, double fixed cushioning with a single adjustable cushioning. You can see the arrow mark also. Okay. Single, double acting. If I want more force, I am connecting a inside only back-to-back cylinder. That is called a tandem cylinder. If I need a more force, double the time. The single acting cylinder, if it gives a one now, for example, F. If I want to get a 2F, then back-to-back two cylinders are attached here. Then that type of cylinders are called tandem cylinders. That type also designs will represent. Now here I'll go for the description of pressure intensifiers like that. Detailed will be shown here. Simplified will be shown like this. So, for example, one type of fluid, or will be having two type of fluids, or air and oil actuators will be there. How will be represented, and how we go for the different walls with the representation. One single square means single position. If I'm having two squares, two position. If I'm having three square boxes, three square boxes, then I represent three position. So like this, we'll go with the description. When I go for this, For example, single direction control was with a single down line, then it thinks that the exhaust port is going on. If I show the two lines on this, if the upper line represents the input supply, down line represents the exhaust supply. If it is crossed also, sometimes I will show in the symbols, sometimes it shows that symbol with the two cross lines. Let me the symbols. Symbols. For example, now you can see in this figure, here I am showing these two boxes, correct na? Two boxes with an arrow mark upward, and here it is showing a T connection, and the arrow mark is crossed, again T connection has come. Like this, if the upper arrow mark shows the input supply, if the arrow mark downward shows it is a exhaust supply, or the oil is going out towards the tank, or the energy supply from the input suction line is going to the input air, like that, input air or oil. Like this, we can show with the arrow marks up and down. If I am showing with the two both by the T section, like this, if I am showing both the ports, input port and output port, both with the like arrow mark, it means the supply has stopped. Neither by input is going on and output is flowing. So both are stopped. If it is cross lines, then I will show like this. Can you see here? Now here, the ports, whatever we are showing here, it is changing this direction. Because of this change in direction, it will show that one time it is connected to A port, the exhaust line is coming from B port. Again the port changes, now it should go, the retracting position changes A side or B side. This I will explain in the board so that you can understand better. Okay, now I hope you are understanding. Okay, for example, if I take this wall, here you have an arrow mark from the upside, downside also, small t also. It means that port is whatever you are showing a T, that is blocked. Okay, you focus on the board, to the board. Okay, now I'll explain you these symbols on the board. Please, I am focusing the camera towards the board. If it is visible or any problem you are facing, please give your feedbacks. I will focusing onto the board. Okay, Ankur. Okay. Now, this is the symbol for single acting cylinder. That both the cylinders you please give. If this is one port, this is a symbol of single acting girl. It is a with a spring loaded. It is having only one port. Okay. If I consider same thing, this is my double acting cylinder. Here I am having two ports. Okay. This is my single acting cylinder. This is my double acting cylinder having a two port. For example, this is my cylinder with a single acting. Okay. This is my single acting where one port is there, one port, and this is in between spring, and a small vent hole is there here. Small vent hole. That vent hole, when I put a K port, it goes outside. Okay. Similarly, when I consider double acting cylinder, this is my double acting cylinder, two ports. It is having both the things with us. It is forwarded. The wall has to change the direction of the flow. When it changes the ports, it will retract. Okay, this is my double acting. Symbolically, I represented here. Now, coming for this walls. Now I am concentrating on walls, especially directional control walls. That is called as, in short, directional control bay wall. We call it as DC walls. Okay? We call it as a DC walls. Now, when the DC walls is there, first I will take the symbol big. If I am writing a square box, this represents one position. If I write two boxes, then it represents two positions. If I write three position, four position, or etc., depending upon your boxes of number of boxes. Now, if I go over here with the position, first you know that single position, single port means the line connected here or here. It is no value. No wall is with the one position. Minimum two positions should be there. For example, if you consider simple example of a single your shut-off walls. Shut-off wall has only two positions on and off. That is only two. Minimum two positions should be there. And when I write it here with the two positions, okay, when I write a position, the ports should be connected here. The ports means input line, for example. Now, you don't think anything. I have a tap here. Water is coming. Okay. The tap, when you go near the tap, usually our assumption is the tap is closed. Correct? It means it is now in normal position. Before you are actuating, it is in the normal position. Then I consider this is my symbol for the tap. This is my normal position. Okay? This is my actuated position. Okay? Before, when you are touching the tap, normally it is closed. After you are actuating, it will become open. So I will show this with a normal, and this is actuated. Okay? Normal. Now, for example, it is connected with the two lines. It is connected with the two lines. The two lines means that is the water is coming top and going down. Now, in pneumatics, you have to see that always I will write here, this is my normal position. This is my actuated position. Is it clear? What I am showing on the board, is it visible? Okay, shall we zoom more? Please speak out. Is it clear?
Visible, ma'am.
Visible.
Okay. Now, this is my normal position. Usual practice is for teaching side. I will keep my right side is my normal position. Left side is my actual position. This is my normal position and thing. So, two positions, that's why I have written two square boxes. Now, always with the ISO standards, my input supply source, I should write like this in the down. The circle and small line. This is the circle and small lines is the my energy supply. Lines with the energy supply. So it is showing here down. I will represent my source as P. Okay? Down, from down to top. My energy supply flows from like this. Okay? My energy supply always start from down to top. Upper part on this box. Okay? Then it is output. This is my input. This is my input. That is my P is input. This is my output. Okay? This is my input. This is my output. Okay. I told you before you are seeing that thing, it is both closed. No water is coming from the top or it is going. Both the ports are closed. I will represent here like this. Have you understood this? Okay? Both ports are closed. No water or no oil, no air is supplying from both the ports. So here, this is closed. So it means my output is now I represent with the letter A. Okay? Now from the source, output, no flow is there. Okay? Now what happens here? Now is this. What you do actuation for this. Actuation manual. You will open the tap or you will open the tap like this. The actuation I will give it on the sides. So this is my push button. The push button I will think the tap is pressing. If you remove, it will close. Okay? Then it is left side is with the spring. Okay? I hope you are understanding. I hope you are understanding this much. I repeat once again. Symbols are very important. By seeing the figure, you will not understand. This needs some explanation. After one or two, if you understand, then you can rest of the things you can identify any type of fonts. So now I am taken here. This is my I represents. I will explain once again. Please concentrate. Each square boxes represents one position. If I write one square box, one position. If I write two square box, two. If I write three positions. Now by seeing that boxes, you should understand that it is having two position wall, or three position wall, or four position. By seeing the ports which is connected, hose pipes are connected, air pipes are connected. That ports it represents how many ports it calls. Ports means lines connected to the lines. Now at present it is having two lines. Okay. Now two position and two. ISO 559. ISO 559 for the symbols says that you should always write ports by position. You should always represent ports by position. Always ports you should mention, then position. Now, in this figure, a wall is having simple, I have taken an example of a tap, just shut off wall. You can call it as a shut off wall. That has two positions, only it is functioning as a only mains on and off. Okay, now as per my imagination, I will imagine always the shut off wall in the off condition. That time it is in the normal position. That time from the supply or to the output it is closed. So this is the normal condition. That's why I have written both the ports with a T connection. only. Don't see the actuated position. You should not see the actuated position. Only normal position. For example, if you are coming to my lab or my thing, what thing I will call you? I will call you with your name. It means you are come, you are having an identification. And that only I am having and calling your name. Because of that name only I should call. It is universally accepted, universally identification. Like that, by seeing the normal position only, you could identify that wall, not by actual position. Okay? By seeing your normal position, by seeing this, you have to see that it is having two poles, two position. It is 2 by 2. Okay? By seeing the normal position, first you understand this normal position. Then I'll explain you actuated position. In my normal position, I have two ports. One port and two port. Two port is connected. It is having two positions. That is by two square boxes. It is having 2 by 2. Now in this normal position, what is my condition of this pump? What is my condition of this pump? Pump is normally closed. Supply is not there. Don't see the output part. Only the supply. Supply is closed. So that's why you should think that supply is closed, normally closed. For example, with your name, your surname is there. For example, it may be a Rao, it may be a something you'll be having. Singh or Rathod or whatever the things is there, then you will identify that surname only. Here, my pump is source. Who is my source? My pump is source. Depending on him only, I should name it. That's why pump is closed. That's why I will mention here normally closed. It is normally closed. After activation, it changes the position. Now what happens? After the changes the position, it will become here. The position was here off. Now it will become on. When it on, that time the supply closes. That time how to show here? Here in this position, I will show here. Next I will show an arrow mark up. I will always, I told you, the arrow mark from down to top. So my supply is open. Okay? example, this is the condition. It is off. Then you are going to open. It will be open. For example, if I consider another example of like this. The tap has two conditions. The tap is closed. You are actuating to open. So I will say this as 2 by 2 normally closed because this is my normal condition. If the tap is open, you are going to close. So this is the condition. Here also 2, but it is already open. In my normal condition, it is already open. So for this, I will call it as 2 by 2 normally open. What is open and closed? That is nothing but with respect to the source. Same concept is continuing from the ladder diagram also. If the ladder diagram, we go that relay contact is open or relay contact is closed. Relay means is a source. That depending upon that we are saying. Now here my imagination is, here I am saying that this is my pump. My pump is closed or open. It depends upon the source is supplying or closed. Depending upon that, I will go for this type of connection. Now, I hope you are understanding. Anything is different, please speak out. I will repeat once again. Is it clear? Okay. Okay. Any doubts? Okay. Any doubts?
No, ma'am.
Now, for example, if I go here, I have here with the two position. Can you see here this wall? It is having two positions. How you name it? For example, this is my antenna. Please remember one more thing I am telling. You have to see the normal position only. Based on this normal position, it has to given by the name of the symbol. So, for example, this is my pump. This is my output. Okay? This is my thing and this is my output. Now, we have here two position, two ports. That's why I'm giving here 2 by 2. Here my source is closed. I will call it as a normally closed. This is my wall identification. Okay? Now I have to see the actuation. Which type of actuation it is there? For example, I will take a push button manually actuated with a spring written. Okay? Now manually actuation means it is closed. When you are pressing, it will move to the actuated position. Can you see now? Okay? I will repeat once again. Now it has become actuated. It is, okay? This is my actuated position. It is pressed. When you release it, because of the spring, it comes back. I am doing manually, but if I go for animation, you can see that whenever there is a press, it moves and otherwise it comes back. So this is the one which is having for the
Excuse me, ma'am.
yes, sir.
Ma'am, why are we writing 2 by 2, not just 2?
It is having two position and two ports.
Okay, 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 ma'am. Okay. Thank you, ma'am.
You
Okay,
should
okay.
write it. Okay. Why I am writing it? ASO 559 says that should always my position.
Ports by position. Okay, ma'am.
Okay. Two ports and two
Okay.
position. For example, why so gone? Condition that shut-off valve which is closed after your actuation it is opening. Now I say the another condition shut-off valve is open, you are going to close. For this, hit to opposite. For this, you have to go for the another condition that normally closed. For example, you can show here. This is already open. You are going to close. So for this, I will call again two ports, two position, 2x2, but it is open. The source is open. Maybe it is moving from the output to source. Maybe because of a closed loop system, it is recirculating inside. Now this I hope you understand 2x2. Okay, shall I continue for 3x2?
Yes, ma'am.
Yes, ma'am.
No. Now, for example, I will show the 2x2 here with the single acting cylinder. I take a single acting cylinder. Single acting cylinder. I know that single acting cylinder is a spring loaded like this. So I will write on this term. Okay. Now I connect the ports. It is a single acting. So I connected here. This is my source. This is my output. This is my P and this is my A. This is my normally 2x2 1. Okay? I hope this is you understood. Okay? Single acting. Now what happens? See.
Yes.
In this normal condition, all my exhaust air is it's a blocking there. Okay? When I press here, see, when I give the actuation, the port pump is connected to output. Output connected air goes and piston moves. Okay? Clear? This is my actual position. Okay? Now, it is in the normally closed because of the spring it is pressed, the air supply. When air stops, the spring, when I remove my actuation, it comes back with the spring loaded. That time what happens? It cannot come back. Is it come back? The piston comes back?
No, ma'am.
Stop here. Okay? It is blocks. For example, if I have a wall like this, it may go for this thing. Okay? I hope you are understanding. For example, that's what I told. Shut-off wall is only two ports and two position. Is not having anything with respect to the cylinder. It's just an open and close. It's just an open and close. Okay? Clear?
Yes, ma'am.
Okay. Okay. Now I will show. I want to activate a single acting cylinder. This is my single acting cylinder. I want to actuate. My intention is that whenever I press, the machine has to punch, and whenever I remove my hand, the machine has to go back with the spring loaded. So for that, I need an exhaust valve, isn't it? I need an exhaust valve. So I will take now a 3x3 ports valve. Okay? Have you seen here now? Now what I have taken here? I have taken a 3 ports. 1, 2, 3 ports. 3 ports, but 2 position only. 2 square boxes only. The ports increasing. By seeing this, I told you, arrow mark upward means source. Arrow mark downwards means exhaust or tank. Now I connect a tank if it is hydraulic. If I connect a pump, that is my source. This is my output. Okay? Clear? For example, this is my pneumatic. Just you remove this tank symbol, you connect an exhaust without filling, you write a symbol R. This is the only difference between pneumatic and the hydraulic symbol. Okay? Now, only with respect to the source, with respect to the exhaust port, only the difference between pneumatic and hydraulic. Rest of the numbers, everything same in the hydraulic. If I remove this, if I write a tank symbol T, then it represents hydraulic symbol. If I have a pneumatic one, I should write a without filling arrow mark. Arrow mark should not be filled. It write a letter R. R represents exhaust. This air is exhausting outside the environment. So this is the one which is going for the symbol. Now how to name this? I told you. Always name with the ports by position. Now how many ports in this wall? Please count. 1, 2,
3.
3. Positions. 3
2.
by 2. Very good. So now source is in my actuation. This is I told. This is my normal position. This is my actuated position. Normal position only you should see. You should never see the actuated position. So in normal position, the source is closed. The source is closed means I should write normally closed. Okay, clear? Now what happens
Yes.
in the cylinder? And now what happens in the cylinder, I will tell you. Now like this, the air has exhausted through R. Fully the air is exhausted through R. Now when I actuate, okay, the force changed. Who changed? The wall changed. Actuator does not have nose. Only the wall is a control. The wall is changed. Now my pump is connected to output air. Air starts. Air starts. The piston moves. Okay? Clear? Piston move. Now, because it is having only one port, the other port should be closed. That's why it is connected to T. Because one way road means whether the vehicles are coming, other vehicles has to stop. When the vehicles are going this side, that side vehicles has to stop. Like that, here, because of single port in the output, the exhaust is closed, that time pump will open. When the piston is moved, I remove my actuation. I remove my hand, it comes back with a spring. It comes back with a spring, that time the port change. The port change, now my pump is connected to, my pump is blocked, exhaust is open. All the air comes back and exhausted, or it may be to the tank. You can imagine anything. You can imagine anything. Okay? How you name it? 3 by 2 normally closed. Okay? I hope you understood. Any doubts?
No.
This is the example where you imagine a punching machine. I press, the piston has moved down, punched, and it is moved out. Now you imagine a bus door. Always the piston is outside. After you press, the piston comes inside. Or actuator comes inside. How you can name it? How you have to design that? Now my application is my bus door. Okay, my bus door is open. Okay, single acting cylinder only, you just imagine. Okay, it is like this condition. After that it has to come. So what I should do?
Ma'am, 3 by 2 normally open.
Very good, very good. Now this is my wall. This is my pump. This is my tank or exhaust, whatever you imagine. R tank. Okay. This is my output A. That I connected like this. Correct na? See, before your actuation, it is already open. Okay?
Yes, ma'am.
When I press, what happens? When I press, the port changes. The port has changed. Okay? Now my pump is closed. Whatever the exhaust is connected to tank or exhaust, that time the piston moves inside. This is the condition there. Okay? After that, when I remove my actuation, it comes back and comes to the normal condition. Again, the piston moves outside. How you name it? This is called 1, 1, 2, 3. 3 by 2 position only. Now I am showing only 2 position walls with the different ports. 2 ports, 3 ports, 4 ports, 5 ports. I will increase like that. This will remain constant. Position remains 2 only, but I keep on changing the ports. Okay, clear? Okay, we'll take a small 10 minutes break. Okay, shall I take a small 10 minutes break?
Yes, ma'am.
Yes, ma'am.
Shall I continue? Shall I continue?
Break for 10.
10 minutes only, please. Okay, come back after 10 minutes. Hello? Can you hear me? Hello?
Yes, ma'am.
Yes, ma'am. Yes,
Yes,
ma'am.
shall we start the class, sir?
Yes, ma'am.
Okay. Now, for example, I was explaining you the 3 by 2 wall. For example, I started with a 2 by 2. Okay. Here I told you this is my normal this thing, and here this is my actuated position. Number of ports are connected like this on the top. Always says that for our better understanding, always you should represent the square boxes by position. Ports connected on the top, it is always output. The port connected down is my source and exhaust. Okay. Now, seeing these ports and by seeing the things, we have to imagine that this is 2 by 2, 3 by 2. I go for the next. I wait for these two type of walls. 2, 3, 3 by 2 walls. In this, we have to see that in my normal condition, whether my pump is open. Depending upon the pump conditions, it is 3 by 2 open and 3 by 2 normally closed. So, similarly, when I can imagine this same thing, this is 3 by 2 normally open, this is 3 by 2 normally closed. If I want the piston to be side, retracting position, I should use 3 by 2 normally closed. If I wanted to use the piston in the extending position, then I should use normally open. This is with respect to single acting cylinder. Please remember, this is with respect to single acting cylinder, single output. Okay? So we'll imagine some of the walls with respect to double acting cylinder. Double acting cylinder, then what I should do? Can you see this side also, ma'am? So this one we can remember it as 2 by 2 normally open, 2 by 2 normally closed, 3 by 2 normally open, 3 by 2 normally closed. Yeah? Now I take this one. Yeah? I'm taking a double acting cylinder. A double acting cylinder has 2 ports. Here, double acting cylinder has 2 ports. Okay, it means what? Means the wall should have 2 outputs. So I will imagine here. Now, you see this wall is having 4 ports. 1, 2, 3, 4. Okay?
Yes, ma'am.
By seeing this arrow mark, the arrow mark upward is a source. That I call it as a pump. And arrow mark downward side, we can imagine a tank or it is exhaust with the letter I. Okay, clear? Then these 2 outputs I will connect to a double acting cylinder. Clear? Okay. Now I'll show you how to number wise and letter wise. This is my outputs A, B. Okay. Now you know that the only the difference is with respect to P and R, except that source is P, outputs are A, B. Now I have to number wise also. Ports I should give number also. Pump is always 1. The source is always 1. Okay? The output with respect to this VA will be given as source 4 and 2. So remaining when I go for with respect to the pneumatic valve, it is R. With respect to the hydraulic valve, it is 3. Okay? This is the one which is numerically letter wise and number wise. If similarly, if I go for 2 by 2 wall, then I will go here as a pump and output. So I will number it as 1 and 2. Only 2 ports it is having. Okay. Similarly, when I go here, this is my pump, this is my tank, this is my output. So number wise, I should go here P1, this is 2, 3. Odd numbers is always represented with the source and exhaust. Even numbers is always represented with the outputs. Similarly, same thing go for here also. If I consider pump, exhaust and R, that is exhaust R tank. So number wise 1, 2, 3. Here you are thinking that 1, 2, 3 means B has to come for the 2 and 4. No, we have to give the preference for A. That's why it is orderly, which is given by the highest number, and B will the lowest number. This is a numerology. When we go for the controls, that also makes sense. I will show further the actuation. Now I am going for manual actuation. I will go for a push button with the spring loading. Okay. Now, whenever I go for here, this is my normal condition. The piston is inside. My pump is connected to B side. That's why the exhaust air is moving here. It pushes the piston inside. Whatever the exhaust is here, these goes are oil connected to the tank. Now, this is called as my normal condition. In my normal condition, my pump is connected to B side and A port is connected to tank side. It has 4 ports. 1, 2, 3, 4. That's why always ports by position, I will write 4. It is having 2 positions. I am explaining all the 2 position walls first. So 4 by 2. Now it has 2 positions. In this position, the pump is connected to B side. That's why the piston is in the retracting position. When I give actuation, okay, when I give actuation, now my ports is changed. My pump is now connected to A. Now B is connected to tank. Now the piston starts moving. Okay, this is the condition in the actuated condition. Now my pump is connected to A. B is all the exhaust air or tank oil has gone to the things. Now it is in the extending position. So this is the condition. Now second time when I remove my actuation, because of the spring load, it comes back to its original position. Here again, it has changed its position. Now my pump is connected to B side. Again, oil will circulate this side. It pushes the piston inside. When it is moving, all the whatever the air or oil moving to the exhaust port or tank port. So it is in the retracting position. Now, pump is always connected to A side or B side. It is always in the line. That's why we should not mention normally closed or normally open. Only 4 by 2. Here, the pump was open, that time exhaust is closed because we have only one output port. Second one, the pump is closed, output is open. That's why we have to use 3 by 2 normal, 3 by 2 normally closed. Here, in 4 by 2, the pump is always connected to A side or B side. That's why always we should write, mention only 4 by 2, no normally open, normally closed. So only 4 by 2. This is disc operated valve. It is, when I show the cross section of the walls, it is a disc operated valve. Now, in hydraulics, it's okay. It is having the things which is working function. In the case of pneumatics, what happens? Sometimes we want the movement of the piston should be speedy. We have to go for the speedy. Whenever the concept of in pneumatics, what happens? Whenever the air exhausts, as soon as this exhaust port, the piston speed increases. For that, they constructed a spool operated valve which is having more advantages than the disc operated valve. This is a spool operated valve. This has 3 advantages. One is because of the spool construction, the cost decreases, leakage is less, and speed increases. Because of the 3 reasons, wherever we need the operations with the speedy actions with the 2 positions, whether it is in the hydraulic or pneumatic, we go for 5 by 2 valve. How we have to identify? I told you, you have to mention only in the normal condition. It is having 1, 2, 3. This is 5 can go for a tank symbol or exhaust. So I will connect here tank E. Another is also tank connection, but it is, I will explain you how it works. Now it is closed. Now you consider this is also tank. Okay, both tanks are internally connected. So let it be here T1. Now my pump is connected to A side. Another it is connected to B side. It is having a two exhaust port, but in one position only one exhaust will be open. This is an example for a classroom. It is having two doors. Whenever we have inside and one more side exit, that side another exit should be closed. One more time, when you change these conditions and pump is connected to B side, my output port is connected to again to this here. That will be open. Another will be closed. Okay, I'll explain once again. This is how it works with the function.
Please tell the numbering once again.
Yes, sir. I will come back. To 5/2 wall. I will explain this. With respect to the animation. With respect to the working condition. Now I know that arrow mark I should represent with the source P. This is my, imagine this is my exhaust R. This is the one more exhaust that I will name it as S. For example, in the case of pneumatic. Now I have numbered P, A, B, R, S. If I imagine this one, we'll be considering a tank symbol here. T. Okay. Now, for example, I will take this with respect to the R and S because numbering will be easy. Now, in this position, I will take for explanation, I will take a manual actuation with a spring return. Now, my pump is connected to the B side. It means the piston is in the retracting position. Whatever the exhaust port is open, so exhaust air is connected to the R. That time, my S will be closed because it is not connected with the output port. So S will be closed. Okay? The second time, when I give the actuation, the pump is connected to A side, air starts or oil starts, it moves the piston to the extending position. That time, whatever the air or oil, it is moving towards S. That time in this position, S will be open, R will be closed. Okay? I hope you understood. It has two ports, but single exhaust will be open in only one position. If in this position S is open, in another position R will be open. Both will be not open at a single time. So this is the condition in the extended position. Now I will remove my actuation. After removing action, my spring load brings back to its original position. That time again it changes. And my pump is connected to B side. It comes, whatever the air is coming here to the R side, and S will be closed. How to number? We'll show like this. We'll show with the normally like this only. P is 1, 4, 2. I told you odd numbers is given for this. This is numbered as a 5 and this is 3. Okay? 1, 2, 3, 4, 5. Like this we number with the 5/2. Okay? Now this is having 5 port thing. So we should call it as 5/2. Okay? Only 5/2. So now today you understood 2/2, 3/2, 4/2, 5/2. Okay? This is my 4/2.
Odd number is given to the pump and the tank, and the even number to the ports. Is it like that?
Output ports. Correct. But pump is 1. First number. Exhaust is 2, 3 and 5, and even numbers is given for the things. I'll tell you why actually you are imagining 4, 2 and 4. No, it's not like that. By seeing the controls, we have to change it. That also is explained. Now I am showing only the ports. I will not come to the actuations. Now only manual actuation I am showing. Okay? I hope you understood this 5/2.
Yes, ma'am.
Hello?
Yes, ma'am. Yes, ma'am.
Any doubts?
No, ma'am.
Only symbols. Still I have to show the cross sections. Okay. Still, I have to show the cross section. As the cross section shown and respective to the practicals, you will understand what is how it will act with the thing. This is 5/2. Okay. Now, I showed here all 2-position balls. Now I go back to your 3-position ball. Is it same? Now you see the 3/2 one, 3 position and you can see here now I have shifted to 3-position ball. This is especially works out in the hydraulics where this is called neutral position. The middle one is called neutral position. Even though it is in the neutral position, there is a circulation of the oil which is shown in this middle position. For example, if I take this is a pump, this is my tank, this is my AB, that is output ports. The oil may be circulating from pump to tank and it is going from the source to the thing. Here, everything A, B, R, P, it may be moving toward the tank. Here, all may be neutral, no circulation in between. But here, maybe from A and B, it is moving towards the tank. So this is a neutral position. Now, the neutral position is now in a normal position. Who represents this wall, I have to number here, not in the left side. Okay. Now, as you are giving the numbers are letter wise in the left of the box, that is my normal position. For the 3 position, now you have to go for in the neutral position. Okay. But symbolically, you are not understood that which is my normal position. For that, you know that from the obviously this is not a push button. It is having a lever operated or detained switch. For that, how will represent like this small? It means it is a detained. Detained means D-E-T-E-N-T. Detained means it will be remain there only. Again, you have to push back to come to the original. For example, emergency stop. Let's see in the emergency stop. Once you press, again you have to press to bring back its normal position. Like that, it is having a groove and middle one is normal position. For that, symbolically a small line will be there that shows this is my normal position. Okay, I repeat once again. If it is having 3 positions, then it is obviously it is a detained lever operated and detained switch. In that, it is having a small groove will be there. That groove represents it's a detained switch, and a small line represents this is my normal position. Okay. Similarly, if I imagine here 4-position wall, now you will be having a doubt here, which is my normal position. Okay. For that symbol says a lever will be having a small. Here, this is my normal position. Here, one small line will be there. That where you have to go here, and you should represent here E. This may be a tank, here AB. If it is pneumatic wall, it may be having an exhaust port R and S. Okay, this is the one. This is very important. This shows that what type of actuation you are giving. Whether it is a detailed switch or a push button, which is my normal position. Okay, this represents a symbolical representation of 2/2, 3/2, and 4/2. So you can imagine this type of symbols, which we have to go number wise and letter wise. And now Now, after this, I will explain you the cross section of each walls, directional control wall, how 2 by 2 work on, how it is disc operated, or ball operated, whether it is puppet wall, or it is a spool wall, what is the advantages, which is my neutral position, what is the movement in the neutral position, how we are going for the different type of activity. Now, I'll go explain, if taking a 2 by 2 wall, I'll explain what are the different type of actuations. For example, I have here 4 type of actuations. If I will take a normally, you will imagine 3 by 2 wall as my start sensor. Why always 3 by 2 wall as a start sensor? Because always it is closed. When I actuate, it should open. For example, I have taken a single acting cylinder, you think. Just I have taken a push button. Okay, spring written. This is my pump. This is my tank, T. This is my output, A. This is my spring written. Now, whenever we go for this, here, if I have a push button, it is connected to single acting cylinder. It is a spring loaded. Okay, it is a spring loaded. Whenever I press, it moves, the piston moves. At time exhaust or tank will be closed. Again, when I remove my hand actuation, it comes back with the spring load. That time a pump is closed, that exhaust port is open, a tank is open, the piston automatically, it will be opened here, it comes back to this original position. This is my manual. Now, for example, I push the push button, it should not come back, so I will make this only as a detailed switch. So, this is my manual actuation. It may be push button or it is a detailed push button or it may be lever operated. Okay? Or it may be pedal. It is like the foot will be pressing the brake. These are manually operated actuations. Now, similarly, this comes under the manual actuation by hand or by foot. Okay? Now I'll go back for the actuation with mechanical. The spring is a mechanical. I may have a wall with both sides spring operated. It may be operating with a thing. But usual practice that one side pneumatic or mechanical or hydraulic or push button, another side spring. Always it is common that we have this thing. Now I have actuation here, mechanical. My actuator should go here and I should get a confirmation it is extended fully. I will keep a mechanical limit switch or this thing. That time it will be pressed, we will get an actuation, we will give a signal. That wall has to give back the opposite side signal. So that time we go for a mechanical actuation. This is the 2 lines and this is the representation of a limit switch or roller operated wall, mechanical operated. Please remember, don't confuse with a pump. It is a single line and circle. This is, the circle is bigger here, but here this is little bit small and but 2 lines. This is my mechanically actuation, roller operated wall. It is kept near the contact sensor. We call it as a contact sensor. Whenever the actuator goes and presses that roller operated, that time it will be pressed and signal will be given to the output. That is called mechanical actuation. Mechanical actuation has 2 things. One is limit switch and spring. Both are comes in the mechanical. Now, I want to operate a wall with indirectly. For example, it is little bit far from my machine. So what I do, I will take a controller. I will take a pneumatic control wall. I will take again a 3 by 2 wall. This is my sensor, manually operated sensor which is operating by push button. Okay. This is my P. You think this is my R. This is my single acting cylinder. Now what happens here? Now I am indirectly controlling. This is I am start sensor. When I press this push button, a pump is connected to output. This goes as a control. That's why I should give the name Z. Control. Now this control gives the actuation to the next one. Now my pump is connected, it gives back to the piston, it moves here. After this actuation, this is also spring loaded, this is also spring loaded. Whenever I go this, again, this is a push button, it comes back here, the spring load. That time, whatever the air is there, it is exhausted to this. This is also spring loaded, this comes back, and here also it is connected. That comes back to the piston retracting position. This indirectly controlled valve is called as a pneumatic control. If I am not filled this arrow mark, only it is open, then it is pneumatic control. If I change this to hydraulic valve, simple, you have to fill this, you have to replace here by tank symbol. What is the difference here symbolically? This is pneumatically controlled valve. If I drive this is hydraulically controlled. What is the difference in the control? Now, for example, you know that numerically, I have given the numberically, I have given Z, alphabetically, I have given the Z. Here, pump is 1. If I take this is a 3, this is 2, pump 1, 3, 2. Now, my control is coming from here, connected 1 and 2. So that's why my control is moving. My pump is connected to 2. My pump is connected to 2. So number wise, Z is represented as 1 and 2. Don't spell it as 12. It is, my pump is connected to 2. That's why it is 1 and 2, Z. If similarly, if I replace this by another pneumatic control valve without spring, now I will call it as a Y. That time, my pump is, my exhaust in this condition, my pump is nowhere connected. That's why we should give my pump is nowhere connected 1, 0. You should not spell it as 10. If it is connected, for example, if I take a similarly with a 4x2 valve, another control is coming from 3x2. If I imagine this is a double acting cylinder, okay? This is my pump, this is my exhaust. P, R, A. I'll show you the pneumatic valve. This number will change now because I have both the controls. Now I have taken, instead of 3x2, I have taken 4x2. See my numbers how changes. Now I connected here, the pump 1, exhaust R is 3, here 1, 3, 2, here Z and Y. Okay. Now, whenever this is a indirectly controlling, for example, you have a controller, first press this, pump is connected here, it moves to the actuated position. Now pump is connected to 2, it is connected here. Now this condition where the push button, it is spring operated, it comes back to its original position, but this will not come back. This condition is called latching condition, and 4x2 valve is called as a memory valve. Call it as a memory valve. Until unless another signal comes back, the spool will be not, this spool will be not operated again to the normal condition until unless it will be in the memory condition. This is called memory valve. Okay? Now, my controls. Now my pump is connected here. Pump is connected to 4, A side. That's why 1 and 4. Another condition, Now Y will be, now my pump is connected to two sides. So it is 1 and 2. That's why I told you in 4/2, we cannot number it as a 2 and 4. Here, when it comes out for the pneumatic control valve, we'll get a confusion. That's why to avoid that, A is taken as a preference, A is given as a 4. To avoid that final control elements, or when we go for multi-stage, always this is a called as a 4/2 or 5/2, which is a memory valve. That's why we have to give preference for the A. Now, if I consider A as a 4, then controls also work with the 3/2 and 4/2 valve without confusion. That's why we have to go like this number system and letter system. I hope you understood. I will repeat once again what is meant by memory condition or latching condition. So for example, you imagine I have a bus door which is operated by the two push buttons, which is it should be open until unless I will operate it with another push button. If I think this is my start button, this is my stop. The normal conditions like this. First, when I start here, the pump is connected to A side. This my control here will move. This pushes to this actuated position. That time my pump is connected to A side. The control is named as 1 and 4. The piston is connected to the pump, gives air to the A side. Piston moves. This is spring operated valve. It comes back as soon as you remove your hand. This comes in normal condition. But this remains in the same condition until unless I stop. So this condition is called latching condition, or 4/2 valve is called as a memory valve. Now after operating another side control, that is my stop condition, again I press this. This brings back to its normal position. That time my pump is connected to A side. This is a push button. As soon as you remove your activation, it comes originally to the normal position. Now my pump is connected to B side. The piston comes inside. All my exhaust air are whatever the tank air oil moves to the exhaust port. This is condition which is indirectly controlling with a pneumatically actuated. Similarly, if I close this, it will become hydraulically controlled valve. Only the numbers will change, letters will change. Instead of R, we have to connect to the tank. This is the same thing which is happening with the whatever you are going for machines which is having two push buttons, start and stop, on and off. Okay, I hope you understood. Any doubts? I show the cross section of all the walls, 3/2, 4/2, 5/2, how it is design wise, how it is disc operated, what are the advantages and disadvantages, how it is spool operated, how we can reduce the cost, size and thing. Next, I will go for the last actuation, the same wall with the solenoid operated. If I consider same wall with the solenoid operated, whatever the spool is there, which is moving, that spool is extended further, it is coiled and it given to a supply. Okay, given to a supply. Here also, it is coiled, it is given to a supply. Usual practice is that our pneumatic and hydraulic valves working with the DC supply. So we have to give a DC supply which is as polarized. So we are giving for a particular positive negative. Please remember, coil does not have any direction. So you can interchange any direction. So it is just a coil, it is a wire, you can change any direction. So this is given for the supply. Please remember that usual practice for mechanical people, it is difficult to understand. So always we say that with a red color positive and blue color with a negative. The usual practice, this coil is not having any direction. You can give any one side positive and negative. This is the construction for solenoid side. Symbolically, we give a cross line. If A is having a rectangular box with a cross line, you should think it is solenoid box. So now we studied the valves and also 4 types of actuation. One is manual, mechanical, pneumatic, hydraulic and solenoid. Okay, these are the valves with 5 types of actuations. So now I show you in the animation how this will work with the symbolical. Then I'll show the cross section. Then we'll go for the simulation of the things.
You're going to show this one or in computer?
In first year. Now we'll show the animations here, how the symbols will be
This is okay.
on this. Okay, sir. Oh my goodness. This camera has.
Camera has to turn on. No, camera has to be shown. You are showing on the PPT only.
Okay, sir. Okay. So here, different shapes will be shown. As I told you, this arrow mark will be the T type. Arrow mark will be up or with the closed lines or dash lines. These shapes and lines are related to the proportions shown, make up and set of the basic symbols. When I go for this, these are the different type of circles which is maintaining for the limit switch, mechanical link, measuring instrument and energy sources. If I have an energy sources like a pump, I will show a big circle. If it is an indicator like a pressure switch, pressure gauge or something with a small circle, if I am showing the same thing with a small circular with a limit switch or idle return roller, then I'll show a small circle. The dimensions is shown with the according to the ISO. Now next, when I go for this square boxes represents the position. If it is a tilted with the angular 45 degrees, then I'll represent with the connection with the proximity sensors or with the filters or with the dryers like that. If I show a rectangular boxes, then it represents a cylinder or the 2-position valve or 3-position valve. Like these symbols will represent according to the shape of the geometrical shapes. Now, for example, if I show a small rectangular boxes, these are the indication. These rectangular boxes with a variable cushioning type or a solenoid wall with a cross line and piloted. I'll explain you what is meant by piloted. The piloted control is shown by the arrow mark, that is represents an air. Air means it is first manually operated. A small air goes and actuates the other wall, that is called as a internal piloted walls. It may be two types, internal piloted wall or external piloted. Internal piloted, it is constructed inside construction. External piloted means the signal is coming out from the some other wall, like a sensors. That is called external piloted. So, now, similarly, if I show semi-circular, then it goes with a semi-rotary type of actuators. It is having an angular motion. A capsule type of this semi-type, then I will go for the accumulator or anything. Double lines means like for double lines for the piston or thing. Now, when I go for here, lines. If I have a dark line, that is called working line, pilot supplier, return line or electrical. If a dash line, it is shows with the piloted control, leader, type of leader thing for the filter thing. Chain means it is having a fully blocked inside the box. That box contains flow control wall and NRV. I will show the symbol of flow control or NRV. I will go back. Now some lines with a dark line on small push button type, RSE, like letter slant E, then that line shows the electrical connection. I hope you are understanding. Any doubts? Hello?
No, ma'am. No, ma'am.
No? So shall I go? Proceed?
Yes, ma'am.
Okay. Now, next, when this type of triangular I have shown, spring and arrow, you can see now, you can imagine that how we are writing the spring loaded, whether it is a hydraulic fluid or open or cylinder or valve, how it is the spring and arrows shows the direction. T is the closed part. Restriction flow, arc, like arc. Arrows with a different type of rotations like this. So this is actually symbol of NRV with the spring loaded. This NRV means non-return drive, like a diode. It moves only one direction flow. Another side, the flow will be not there. It is only in the one direction. But when I press the hose pipe, it opens. The ball will come back. Or disc will come back. Again, and remove the hose pipe. It blocks the port. That's why it is spring loaded. This is called NRV with spring loaded. Sometimes NRV with the spring loaded, without spring loaded. It may be having both type of things. Now, for example, if I show a temperature like this is circular, operated, prime movers. This is the one single, four-way junction, crossing lines, fixed air bleeders, air exhaust, connections like this, coupling quick release, both are exhausted, but source sealed, coupling quick release self, like this type of symbols will be seen. That is rotary one connection, rotary connection two lines, rotary connection three lines like this. Now we can go for some separators or conditioners, water separator with a manual drain, water separator with automatic drain, filter with a manual drain, filter with an automatically drain, or lubricator. You can see the difference. All are a rhombus type with a tilted with the square boxes with a 45 degree. This small line indicates this lubricator. Okay. Here, filter, dotted lines with a filter and automatic drain. Automatic drain means you are having here one more, automatically it is closed. Here with the arrow mark inside a small box it's not there. So we can think that it is a filter only, but manual drain. Okay. I hope you are understanding. So next, dryer. Dryer, same this type, but two lines. The cooler without coolant or flow lines, heater, combined cooler and heater, plant, isolated valve, air inlet filters, compressor and electric motor both are coupled. M for stand for motor. This is my compressor. This is air accumulator or air reservoir. Isolated valve. This is sometimes we call it as a shut-off valve also. This symbol represents a shut-off valve. Now I can see these pressure regulators. In pressure regulator, this is very, very important topic. For example, if I explain you pneumatic and hydraulic parallelly, if I compare, hardly we are not having any type of pressure valves in pneumatics because we are working in the low pressure. My working pressure is 4 to 6 bar. My pressure line will be having in the starting, I will be having a pressure regulator that I keep it in a fixed, that will be throughout our system. The pressure will be not seen at all. We are working in a safer condition. Only if something happens, only the some small crack will come in the hose pipe or air leakages, then we'll come back and we'll close that main valve and we'll work. If by chance the air opens also, it not harms anything. But in hydraulics, you have to consider pressure related all the valves. It's very, very important because it is the safe valves. Like for example, I have a cooker. If pressure increases, I have a small hole on the top of this near the whistle that will be burst out and will be the cooker will be safeguarded. Like that, everywhere in the hydraulics, you have to concentrate mainly on the pressure related valves, whether it is a pressure relief valve, pressure regulated valve, pressure with the vent hole or with the regulating things, everything with respect to the things, we have to safeguard the circuit and there should be a more prominence given to pressure related valves. The pressure regulator, now for example, this is the one which I am keeping for the to keep the regulating in a constantly variable. Okay, 1 minute. Just I will just mute a thing. Just mute for some time. I have some discussion. A pressure regulated symbol represents a normal state with a spring holding the regulator open to connect the supply of the outlets. Like this will be there. Okay. Now, for example, if I have adjustable, so I can show a adjustable regulator simplified. Adjustable regulator with the pressure gauge. Whatever we are adjusting here, we have to see on the gauge also. So that time a indicator also will be there. Like this, we may have this dotted lines. For example, if I have here the pressure is increased, it has to went through. So the dotted lines gives the feedback also. This opposes the spring and can vary the flow through the wall from full flow through the shutoff to exhaust. Like this dotted lines represents, but by emergency, it is having the pressure more, then it should vent or it should leave that to the exhaust. Like that, the dotted line represents the future things. I hope you are understanding. Hello. Hello, sir.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, sir. Thank you. Whenever you people say yes, then I will get more motivation. Then I will come back to again. Okay. So otherwise, I'll think that I am alone speaking. Okay. Now, when I come back to this again, this is my air service equipment. For example, some of the symbols I'm showing parallelly. This is called FRL. FRL means filtered with the automatically dried, with a regulator, with a gauge, and this is a simplified form of a lubricant. Okay. This is my air service equipment. Very, very important. It is called in the FRL. That is in pneumatics FRL. Filtered, regulated, and lubricated in the combined unit. Everywhere I cannot write this. I want some simplified. So I simplified to a rectangular box with a dotted line and arrow shows this automatically drained. A gauge with the arrow mark, that is, it represents whole unit of pressure regulator with the indicator. This small line indicates a lubricator. This is a simplified symbol. Okay, simplified symbol. Now, this is the one which is pressure relief valves. Pressure relief valves having this adjustable relief with a simplified form. Preset relief valve simplified. After some preset value, you can see this line goes to this parallel to this, then it stops. That is called pressure relief valve with a preset value. Okay. After some preset, for example, punching machine, after 4 bar, the cylinder has to come back. So after when I set this pressure preset value or present sequence valve, that in that sequence it will come back after cylinder air filled. After it acquires some pressure which is presetted. For example, I set the pressure. For this base, I need a 4 bar pressure. That when I set in the preset value, after that it automatically comes out for the things. So this line you can see some small down, it comes parallelly when it is going for the preset value. When it is acquires preset value. Okay. So this is a symbols. Now I'll go for small symbolical representation of actuators. So these are all actuators. Single spring loaded, single with a outstroked magnetic. Okay. Next is semi-rotary type. Semi-rotary type with a single direction rotation. Rotary motors with a bidirectional. Like that we have some type. Now you can see from our walls. Now you are having a different type of rectangular boxes. If it is having rotation, rectangular, square, circular, with the circles also different directions, dotted lines, and all the type of lines and symbols you understood. Now, I'll come back to these wall structures. As I told you, I'll explain whenever I take a 3x2 wall. Okay. Now, wall symbol structures, if I go with respect to all these type of inlet, outlet, exhaust or thing, when I go for this, now I know that I have taken a 3x2 wall because it is having 3 ports. 1, 2, 3. This is my normal condition. This is my operated condition. 3x2 wall, therefore 3 ports and 2 states. 2 states, that is also normal state and operated state, or normal state and actuated state, whatever you can imagine. Okay. Now, again, I may have vice versa, operated and thing. So, both together, it is having normal and operated. When I connect this to wall, I can see that whenever the arrow mark down, I will represent with an arrow down or normal. You can see the rectangular boxes with a triangular here. Arrow mark are like this triangular. When the triangle is downwards, is the exhaust. Like this also some symbols will be there. You cannot imagine the circle and dotted lines. Always in simulation software, when I go for simulation software, please don't confuse with the source and the exhaust. For example, in the pneumatic, when I imagine pneumatic walls, like these symbols also shown. The source is not with the circle and dotted line. The source is always shown with the rectangular boxes with like this. Exhaust is shown with the opposite rectangular, triangular boxes. Okay. Please remember this type of indication is also there in the pneumatic walls. See, now actuation. When I give spring loaded. And together, when I give actuation, this moves to the normal position. I hope you are understanding. Okay. This folder is already shared with your drive, isn't it? Have you opened? Have you checked this? It's opening.
Yes, ma'am.
Okay. So you can see that in Norgen folder, as have subdivision that it is having actuator with the last PPTs. Again, with I'll go for some safety. Again, walls, symbols like that is having 5 subfolders. In that you can see all it is very well explained. Norgen is nothing but a company which is having supplied by the FRLs or some walls like that. So that we are having a good, this is a very good animation. Without a teacher also you can see and you can study, you can come for the things. So that's why I shared yesterday. Okay, any doubts? Sir, any doubts?
No, ma'am.
Now you have to imagine your industry or your working place. There, for example, if anybody is having any type of direction control walls without any indicator on that or stickers or any type of note sheet is not given, you have to be able to understand that by seeing the ports. Okay? Always a manufacturer will give the clue that the exhaust and the pump will be in the downside of your wall. Upper side is output. Wherever the two exhaust, for example, I am taking a 5x2 wall with the exhaust port R and S. In between that input will be there. That is source input. On the above that wall, output will be there. Sides will be the actuations. Okay. Sides will pneumatically actuation will be there. Or hydraulical hose pipes are connected. Or it may be solenoid walls like that. You have, by seeing the wall itself, you will be having some idea that how to identify that walls. Okay. Four by two and 5x2. This is before you are operating or after operating. Okay. Then I went for 5x3 walls. The 3 position of walls is normal. Central position is set for the, I told you, in central position only it is having normal position. It is not manually operated with such as a lever operated or something. You can see here. For example, you can see here it is a lever operated only, but a spring is there. This is called, we can say, manual override. Sometimes when the lever is broken or something, you have to override that position. A spring also is written. For example, a solenoid valve. Solenoid valve, it is given the supply, the solenoid valve given from the wires with the positive negative supply. The supply is not coming. You cannot keep the machine in the on condition. You have to bring it back. That time you have manual override. Manual override, by doing a manual override, it comes back with the force that you are bringing forcibly to the normal condition. That is called manual override. A backside, there is a screw type will be there. You have to take a screw and you have to bring it to the rotation. Then that will become a forcibly to the normal condition. Okay. This is that. Always when the lever has something or push button is not working, that time you have, yes, any doubts? Okay. Now this is a with the manual override. Here also you can see this is my normal condition. This is another position. Okay. See, this is my middle condition. First position, second position, third position. Okay. But a difference is there. You can see the middle position has difference. All ports are sealed, outlet to the exhaust, supply to the outlets. Like this may be change in the positions. Now, I told you, now actuation or operating. General, I told you manual overrides. Manual overrides is always represented by 2 lines with a dash. Push button, push button, push button, pull and push button. Okay. Here lever operated, pedal operated, throttle operated, rotary type of knob. That is, we say that thing. Plunger, roller. This is called unidirectional roller or this type of things. And pressure which is giving, that is pneumatic control, piloted control. Inside only it is having one more thing. This I will explain in the cross section time. What is meant by internal piloted? What is meant by external piloted? I will show in the thing. So I told you the detent switches. Detent in the 3 positions. So this middle position is detent now. Now electrical solenoids. Solenoid with the piloted. Solenoid piloted with the manual override. You can see here. This is a solenoid symbol. It is internal piloted. This is manual override. The cross line, 2 lines with a cross. So this is all 3 combined. So manual override with the internal piloted supply. Okay. I hope you are clearing. You can see here, this is a very, very important. Single piloted with the manual override and external piloted supply. Sometimes you cannot override this solenoid valve. You have to give external supply. Whatever the here, you can see the dotted lines here. A small air will be given from this source to the again to the internal piloted valves. So they are called internal piloted. Please, I hope you are understanding. There is a difference between internal piloted and external piloted. External piloted should be comes from signal from the outside, but internal piloted, that line will be there. From that it is the air will be supplying through the internally. So this is called internal piloted and external piloted. By doing piloted, for example, I'll tell you one example. If I am having a house, okay, not house, I'm having an olden days, if I'm having one, what we say that mahal, or when those Raja peoples will be staying in there, na? Normally they will go in one door. In emergency purposes, they have surang, tunnel type things to escape. That type of things we'll call it as a piloted. Internally we having one more connection in some emergency purposes. Like that, we have to imagine whenever there is an emergency purpose, so that we should have some internal connection, it should override that position. Like that, we have the main door, but usually in some general or some rare cases, you have to go for piloting. So this is nothing but main door and surang mark. आप हिंदी जानते हैं ना? सब लोग हिंदी तो जानते होंगे.
Yes, ma'am.
Yes, ma'am.
जैसे लोगों को, जो राजा लोगों को आपको एस्केप होने के लिए एक पीछे सुरंग मार्ग निकालते हैं ना, ऐसा हमारा एक छोटा सा अंदर से इंटर कनेक्टेड होगा, जिससे हम लोग ओवरराइड कर सकते हैं. इसलिए उसको डॉटेड लाइन में दिखाते हैं. ठीक है, समझ में आ गई?
Okay, yes, ma'am.
हाँ, अभी आपको कुछ भी नहीं समझ में आता है, भाषा को बीच में मत लेकर आइए. आपको जिस भाषा में बोलना है मैं बोलूंगी, हिंदी, इंग्लिश, या आप लोगों को थोड़ा सा समझ में आए तो जिस भाषा से पूछिए मैं बताती हूँ आपको, ठीक है ना। मुझे लास्ट में आपको अच्छे से समझ में आना चाहिए, बस वही तो मेरा एम है, ठीक है। Now come back to port marking. You are asking port marking. How will the port marking will be there? So here the port marking will be given with respect to 2x2 wall, 3x2, 4x2, 5x2. But here you can see here 4x2 wall also we are mentioning here 4 and 2 with respect to the controls. 5x2 wall, A is given the preference 4. I explained all those things with the manual only. I started with the manual only. These are the symbols for the other than direction control wall. Now we are going for the function components. So this is the symbol for non-return wall with the spring. If I remove spring, then only NRV. Okay. It means, for example, you are removing the hose pipe, it should close that port. That time you need a spring. So, madam, from the supply it should come, it should move, it should not return back to the tank, or it should not return back to the pump. That time you will not put a spring, only NRV. So this is a flow regulator with a unidirection. This wall has a combined form of NRV and flow control wall. This both together we call it as flow regulation unidirectional, or it is also called throttle wall or needle wall. Please remember, the second wall is called as a throttle wall or needle wall. Why we calling it a throttle means, for example, I have a punching machine. It forward stroke, that is moving stroke, extending stroke should be very fast. Okay. Or return strokes should be slow downs. That time I wanted to slow downs, not both. If I put a flow control wall, both the strokes, forward stroke and reverse stroke, both will be slow downs. No, I want only forward will be slowed, return should be very fast. That time, go for the, for example, I have a machine, it should come slowly and punches. After punching, it should go back very fast. That time, I should put a throttle wall with parallelly, like that. We have parallelly, we have a flow control wall and NRV. First time, you'll be having only with the function of flow control wall. That time, NRV will be not working. Return line, NRV will block connection. This is called as a throttle wall, needle wall, or it is also called flow regulating for a unidirectional. Next, we will have a flow control wall with a bidirectional. Both sides, air may flow, but it is having restriction. Then, we have logic walls also. What is going to be logic walls? Now, logic means, I hope you understood. Logic means you will be remembering when I have two signals from other side, two push buttons.
Programmable logic.
Yeah, definitely. For example, I have a machine. It is operated by the two persons. Okay. It is far. One signal is that, one signal is here, little bit far. Then no problem. He may start the machine or another person may start the machine. If the signals, control signals are very far, then we go for the or functionally, which is also called shuttle wall. Anybody can operate. Or by chance, both are come, both are pressed, then only machine should on. That type of will be having from the far off conditions. That time we go for the shuttle wall. It functions like a OR. For example, if you imagine your school, college days, that time we'll show a what we have saw truth table, which is having a condition that 0, 0. It means both push buttons is not pressed. Any one push buttons is pressed. Addition. It works like addition. 1 plus 0 means one person is pressed. That time also machine should operate. Or another person is as missed. That time also should operate. 1 plus 1. Both are operated. That time also should work. Like it is logically working. That's why it is called as a logic war. It is. But the machine is one which is having very, very safety operated by the single person. For example, a single person is having two signals to safeguard his hands. Okay. I think you are, I hope you are understanding. For example, CNC machines. CNC machine, you having a both control with a push button and pedal, or with the two push buttons. When the two push buttons pressed, that time only machine should operate. Because by chance one hand is spare, the person is pressed, it should not damage the other hand. To hold or to safeguard both his handles, both the hands are engaging, then only the machine should operate. This safety condition is called as a AND. 1 into 1 only 1, like multiplication. 1 into 0 0, 0 into 1 is 0, 1 into 1 only 1. It means both the signals are coming, that time only machine should operate. That conditions are called as a logical valves. Logical valves are called two pressure valve, that is called as a functions like a AND function, that is AND gate. We say that AND gate and OR gate. Okay. I think you are understanding. All are mechanical, na? All are mechanical. All your batchmates are mechanical.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Sometimes it will come with a mixed, like instrumentation and electrical. That's why I asked. Hello.
No, no, ma'am. All are mechanical.
Actually,
Don't worry about the logics. You just think that two push button you are having. If one push button is pressing and another push button is not pressing, it means it's 0 and 1 condition. Like that, we have to go for this. Forget about this AND and OR. We just remember two pressure valve and shuttle valve. If shuttle valve works in all the conditions, two pressure valve conditions is very safety. Wherever you want to engage with both the signals, or you have to confirm with the both signal, then only the machine should operate, or it should be going for the on condition. That time you have to safeguard that. We have to go for the safety precaution. That time we go for the dual pressure valve or two pressure valve or AND. Okay, clear? Okay. Now next. Okay, now we'll go for this some function of the other than this exhaust ports and this thing. Okay, now what we have to go other than this component, you will be having, for example, in the case of pneumatics, there whenever the exhaust air goes out, it makes some hissing sound like that. Whenever you can see a bus or a vehicle which is in the thing, a quickly air has to go, it makes a sound. For that, we have to connect a silencer. For that, exhaust port has to be connected silencers, that type of silencer with the filters. For example, always we have to take care that input air also will be input air or input oil. That input source also will be very clean, and output also we should be get that all the exhaust ports is connected with the filters and noise silencer. So this is a indicator that it is a silencer with exhaust port. Now, sometimes we want to quickly exhaust some emergency purposes. That time we go for the quick exhaust valve with the simplified silencer, and the air will escape very fastly, making very sound. That is called quick exhaust valve with the silencer simplified. This dotted line shows that it gives the shortcut from the output to exhaust. Now, again, next, when we go for some we related to the electrical. A pressure switches should be having a electrical signals with a preset value. For example, pressure switches. I have to set the pressure. For example, a machine is operating in the 4 bar or 6 bar preset value. Then automatically after preset, it should leave that signal, electrical signal. Then again here also, a signal with the electrical pressure, it should be adjustable. This arrow mark with the things we say that it is adjustable. Only the difference is you have to see the arrow mark whether it is adjustable or thing. Now next, when you go for this, you will go for different type of actuators, solenoid valves, air lines, function, component, vacuum, and electrical and electronic things. It shows that all different type of single acting cylinders with a rotation, adjustable cushioning, bellows to observe the shock observers, which is very much used in the vehicles to observe the shocks. Double acting cylinder with a magnetic, non-magnetic rods, adjustable bellows, and hydraulic magnetic one. Yesterday I showed you the example of reed sensors, which is attached on the cylinder. That is called as a magnetic rodless cylinder, adjustable thing. Then which is going for the different type of with respect to the non-rotating rods and active brakes. Passive and active brakes. Next, we go for different type of cushioning and adjustable things. These are the symbols we have to keep it inside. Once we understand the setup of your industry, you can just for the reference you have to keep this. Rodless cylinder with a different type of carriage, self-adjusting shock observers. So this completes the symbols for all the things. Now in the afternoon session, I will take the cross section of all the walls. Okay. Afternoon session, I will show all the cross section of walls. After the tea break, we have to go for the demonstration of some of the with the 3x2 wall, 4x2 wall, with a single acting and double acting, with the flow control wall, with the throttle wall, with the NRV, what happens, and we'll see the things. Before that, I will request all of you to, whenever I will do simulation, you have to open the simulation folder and you have to cross check. Otherwise, after that, if you get doubt, I will be not there for you to clear the doubts. So simultaneously, you have to work. You are all very young people, very energetic people, all future ONGT, DGMs and DDGs. So I will request everyone, please concentrate. You have a bright future that you have to control all your unit. So that now only we are giving, and I will always pray God that you people will come for the offline training also, and you will enjoy our setup and things, and we'll be having a long life relationship. Okay. I hope everyone is listening.
Yes, ma'am.
Yes, ma'am. Okay.
Yes, ma'am.
Shall we take a break? Any doubts? Before that, any doubts?
No.
Of you all.
No, ma'am. No.
Okay, okay. Okay, 2 voices are coming. Other people are not in class.
clear.
It's very clear. Okay. Now, any doubt is there? It will be cleared when you do practical. See, only if I show the simulation and practical now, we'll be having some doubts. So I'll show simulation. You can design any type of circuits in simulation. Same thing before doing on the practical. Once simulation is confirmed, then confidently you go to the trainer kit and you can do it. Okay. I hope you understood. I will take a small break of lunch. 2 o'clock, you please come back here. We'll complete today's portion. I hope no disturbance from morning.
Yeah, no disturbance.
Okay, okay. Thank you. Thank you very much. Please come back at 2 o'clock. Okay. Okay, I'll close the session. Thank you for everyone. Hello, good afternoon to everyone.
Good afternoon, ma'am.
Shall we
Good
start the
afternoon.
session?
Yes, ma'am.
Okay. All are present. I hope all are present.
Some people has to come, ma'am.
Okay. Shall we play? You have seen all videos? Yesterday I have sent in that videos you have seen. Actually, we have a Festo trainer kits. Whether it is in the hydraulics or pneumatics, we have Festo trainer kits. In that, regarding that, they have given some of the material which I am sharing. In that, we have some videos and simulation software they provided by the Festo people. Okay. So now we have to you see the all the materials today. If you have doubt in your regarding to your whatever the material or valve or symbols, whatever things, tomorrow our topic according to our schedule. Actually, according to the schedule, we have completed the fluids, but reservoir, our power pack is remaining. That I will do it today. Now rest of the things, cross sections I am taken. Now I'll take. Now symbols I have taken. Actuator I have taken. Okay. After completion this, if you are completing today, we have to do some practicals on the trainer kit. Tomorrow our guest faculty, Mr. Joji sir will come. He will take pumps, types and constructions and operation and the selection, and he'll do also pressure relief and pressure controlled valves. And also he will demonstrate a simulation and also on the trainer kit. So today's topic is also very important, and we are doing simulation plus this thing. And again on the Friday after festival holiday, after again Friday, we are concentrating on the accumulators and some circuits. And second half session, we have to learn how to design hydraulic systems. What are the care we have to take? Okay, to take and how to design our things. That design in that session, you can share whatever your industrial circuits with Joji sir. If you have industrial circuit, you want to discuss on that, or you have some problem, you want to go for the maintenance side or anything. He is a trade expert. He knows pneumatic, hydraulic both, and he is also a author of nearly some 38 books. So he is our ex-retired, he is in joint director level. So he will come tomorrow and he will take the class. So tomorrow and day after tomorrow, you please see that you should be discussing with your own circuits from the industries. And also we will be studying a case study for industrial system. For example, what all the things we have to see in the industry side, hydraulics and also pneumatics. No problem. If you ask pneumatics also, you will be able to answer. And Friday last session, that is one more sir, our sir is coming and he is taking on the preventive maintenance and troubleshooting. What things we have to take care in the to a very good conditioned machines or circuits. So this is our brief of our schedule. Apart from this, anything is needed from your side that we can vary. I am asking is, for example, you have something which is not covered in this course. You can see and you can say tomorrow itself. I can include that also. So anything like that, we want to discuss more on the one particular topic, or you are missed out something. I hope you are coming back tomorrow. Then you are giving that feedback so that we can cover. After everything covered, if you say means, we cannot go back to this again to the guest faculty and we cannot call. He is available only for 1.5 days. Okay, is it clear? Hello? Hello?
Yes, ma'am.
Okay. Okay. You have from the different sectors, correct na? You are from the Ankleshwar, Tripura, Rajahmundry, Ahmedabad, Kakinada. So anybody is having any type of things, you please tell us. We'll include in that our this thing. We'll try our best, even though it is online. We'll try our best to discuss all the type of difficulties you are facing in the industries. Okay. Okay. I hope shall I start the class? Okay.
Okay.
Okay. Okay. Now I'll come back to the cross section of walls. Now I was giving you the cross sectional of walls. Now I'll do what are the things it is there in the cross section wise, and some of the simulation we'll see the wall animation and some of simulation on the circuit we can see that. Okay. Now I'll come back to here. In this walls we have different same way. We have different things. Yesterday I sent this material. We have what is the different type of puppet walls, actuator controls, disk operated, and what we go for the more than 2 position walls. What is meant by flow control regulator? Almost all up to solenoid walls we covers this. This is all some of the figures which is available in the industry. Okay, design wise anything. This is I showed also. Now when come back to here, 3x2 wall which actuating, that I showed here, how which will actuate and spring action. This is a sum of the circuit function. 5x2 with a double acting. Correct, na? This I hope you understood. Here he has given the controls also. Can you observe here? The controls is given by 1 and 4, 1 and 2. 1 and 4 is a push button and 1 and 2 is the Y side control or spring return. Okay? Usual practice that push button we are not saying that it is operated with manually. But spring return also it is there. Otherwise we can give the controls also. So this is a cut section of this double acting cylinder. Okay. This is the this is a identification of these 5x2 solenoid valves. Here you can see what I was telling this. This is the one solenoid with the 15 mm. Okay. Here, which is black color, inside the coil will be there. This is a piston. Okay, second one is piston, which is coming out of the thing. And third one is a spool with a disc seals. This is a fully we having extending from here to here spool and spring return. One side another we have here spring return. Alternate ports are 2 and 4. That is my output ports. Pressure indicator will be there. Here some pressure will be there. That is called as a some indicator we can connect or we can go for the thing. Manual override is here. I told you this is the one which is on the top like a screw. If you turn that screw, it will be operated, manual override. Ninth one is my electrical connection. From there, I have to give the supply. 2 ends will be taken out. One maybe if it is DC, it is polarized, positive, negative. Otherwise, you can go for the AC solenoids also. You want to go for high pressures, AC solenoids also is no problem. But please remember, the voltage is directly proportional to number of turns. The coil has number of turns that should be directly proportional to voltage. If you are making according to the setup, the load level changes, size level changes, and pressure level also changes. All these things will come in the things. For example, I was telling this puppet was 2x2 wall. It is having 2 ports. This disc is operated. That's why it's a puppet wall. Okay. This is a actuated condition. When I press here from the signal, it is coming from 1 and 2. That is my signal is coming from here. The signal is coming here so that the wall will be get pressed. When the wall get pressed, it goes here. You can see the spring will be pressed condition. The output from input to output will be flowing, the airflow or oil flow. In the animations, we are showing here with the pneumatic valves or hydraulic valve. Now for animation things, if you see that dark blue, it is nothing but our input here. Light blue is the output or exhaust air. It is better to see in the animation with the color code. That's why I have taken this type. It is common to both the walls. See, this is actuated condition. This is my 3x2 puppet wall. See, it is pressing. This is my actuated wall, the actuated condition. This is a spool wall which is having spool which is like this. The spool has a number of major and minor diameters called as land or valleys. The land here, whatever this will be keep on moving according to the controls. If the control comes, whole spool will be shifted to that side. If the control another side comes, it will be discussed. Sometimes we'll go for the static and sometimes we'll go for the dynamic seals. Okay. Static seal type has seals fixed. Dynamics means it is floating. Like we have to see that that day yesterday we showed color this one variable cushioning type. The seals will be floating in dynamic condition. So disc seals. In the spool with the dynamic seals, momentary. Here you can see here. Now in this case, now when I go for number 1, this is my source. Here, as I was telling, you are imagining that in the symbols, output is on the top. Correct, na? 4 and 2 is on the top. Exhaust, downside is the pump and exhaust. But see in this figure, okay, all are in only one side. It's not in the top or bottom. It's all in one side. Pump, output, last at the end, exhaust. Controls are here coming. You cannot imagine that it may be in the same construction on the way. It may be differs. It may be differs. It may be go for the other things. For example, if I show here, one more example. Here also, all the controls are coming from here. Control Z and Y are coming from here. 1, output ports 4 and 2, and 5 like this. This spool will be operating from here to here. Okay. See, it's in the actuated position. When the control air 1 and 4 comes, the spool will be pushed, fully pushed. That side. Again, when the control comes another side, the spool will be shifted to another side. Okay, I hope you are understanding. This is the one side. Control is coming from, the 12 is coming from this side. That time the whole spool is shifted. Pump to output is open. That time this exhaust is closed. That R is closed, S is closed, R is open. So this exhaust port is coming. For example, see, now for example, I'm having like this. I'm starting from the starting, I'm showing. This is my 5x2 wall, correct na? 5x2 wall. Both side controls they are having. I may have control from the pneumatic side or hydraulic side. Both controls are there. Pump 1. Now pump 1 is connected to 2 side. It means in my normal condition, pump is connected to 2 side. This is live air or oil. That time, exhaust port 4 to 5 is open. 4 to 5 is open. Okay. S is open now. Okay. R is closed. Correct na? Now here the 3 is closed, but 5 1 is open. From that output to A to 4 is coming. 4 to 5 is moving. That time what control is that? That is the control of the 40. When another condition, when I go for another things, will be actuated. That time 4 2, that is my 1 is connected to 4. The input is connected to A side. A side it is going, but exhaust air coming from 2 to 3. 2 to 3. Okay. That time your control has come from another side. That's why this, whatever the 5 port is closed, third one is open. Okay. Clear? Any doubts? Here also you can see the movement when we shift. This is a cross section of 5x2. This is a cross section of 5x2 where the movement of the air from A to B or B to exhaust. Okay? Clear? I hope everybody is understanding.
Yes.
Yes,
Okay.
ma'am.
Okay. All are present? All are present? Shall I call out the names? Because I have to give the attendance.
Okay, ma'am.
Okay. Pandeji?
Yes, ma'am. Present, ma'am.
Thank you, ma. Sai Kumar, present. Gagandeep?
Yes, ma'am.
Yes. Sadda? Anand?
Present, ma'am.
Manoj Yadav?
Yes, ma'am.
Okay. Sapnali? Sorry, Sapnil? Sapnil Ugamule?
Yes, ma'am.
Jitendra Kumar? Somraj? Somraj Soni?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, no problem. Akash Singh?
Yes, ma'am.
Kevin? Kevin?
Ma'am. Yes, ma'am.
Okay. Okay. All are very good students. Okay. All are present. Thank you. Shraddha, can I hear your voice, ma? Shraddha Tiwari, are you present?
Hello, ma'am.
Okay, ma. Okay, ma. Thank you, ma. Thank you. Okay. Okay. Again, I'll go back. I have taken the attendance. I will go back again to the. Okay, ma. Okay. Now, when I go back to this again this one, you can see here, if I am going for this spool or static seals, the seals will be in the static condition. Only the spool will be having. See, this is what is the type of wall here. Now, identify the wall. 3/2 normally closed. 3/2 normally closed. Here the control changes. Please remember, in 5/2, the controls are 1 and 4 and 1 and 2. But similarly, when the 3/2 comes, the controls become 1 and 2 and 1 and 0. Don't spell it as 12 and 10. 1 is nowhere connected. 1 is nowhere connected. That's why the control is 1 and 0. In these sides, now 1 may be connected. When the actuation comes this side, that time the spool will be connected to, see, now 1 is connected to 2, correct? In another condition, see, 1 is connected to 2, second one, it is, now 1 is nowhere connected. Like this, we have to give the controls. Controls are letter wise, it is controls are Z and Y only. Your left side is Z and Y side is, right side is Y. But if we give the number, you should keep that 1 stand for pump, 2 and 4 and 2 are the outputs. How it is connected with respect to 3/2 and 5/2, you should take care. Okay. Again, now I'll go for another things. Balanced spool type. See, here also we can say this has different construction. Balanced one, where we have to see that usual practice that when control error, for example, control error is coming from the push button. If that push button is spoiled, in this construction, there is always a manual override also. That manual override, I will show another figure which is having manual override. This is a 3-position wall. Can you see here 3-position walls? Similarly, I'm showing. Now here I finished two positions. Now we go for the dynamic where it is having the 3 positions also. See, you can see here 3 position. I told you, as per our thing, the middle one is normal. There you have to go and designate with the numbers or letter wise. Both side. Here for the for animation, he has shown with the spring. Okay. So this one is 1 position, that is in the neutral position. Neutral position, here also it has blocked, here also it is blocked, no supply or no outputs. So all are blocked. If I go for again in this another thing, you can see it is moved to the left, one of the position. If I do another side, it comes back to the other position. Usual practice is it comes to the neutral position from that side at another side. I'll show practically one wall which is called as a butterfly wall. In that you can see the positions which is changing. 1 minute, I will bring the wall. Now, can you see I am holding a wall? You have to identify which type of wall this is. Now, this is a wall which I am holding. You have to see. Now, you have to tell me which type of wall this is. Now, from the morning, I teach you 2 by 2, 3 by 2, 4 by 2, 5 by 2. Now, I am holding some walls. Now, your test is starts. Now, you should tell me which wall I am holding. Okay, you can see carefully.
2 by 2 normally closed.
How you told 2 by 2?
There are two positions.
Very good,
Two ports.
very good, very good. 2 positions. That is my push button, 2 position. And now ports.
2 ports are showing there.
No, one more port is also there. Observe carefully. What is this?
Acha, exhaust.
This is 3 ports. 3 ports pneumatic valve. 3 by 2. I told you 2 by 2 only shut off valves which is available in the near that source or pump or FRL. It is near the FRL. I have only controls to open and close the supply. But as per the valve I am actuating, I am having here 3 by 2 only. 2 by 2 only 2 position. 1, 2, 3. Third, whatever the exhaust port is there, that is always connected with the filter and noise silencer. Please remember, filter and noise silencer. This is 3 ports. If you observe carefully, you can see here numbers also. Here it is letter wise A, P, R. You can see here A, P, R. Okay, like this number also will be there, letter also will be there. Now I am holding one more wall. You have to identify now. Okay, you have to identify which type of wall is this. Can you see here?
Five by 2.
Very good. What is this type of actuation?
Lever operated.
Okay, see, this is lever operated. This is detain switch. Detain switch means it will stay there only until unless you change. This is a push button.
Understood. Understood.
Okay, this is a detain. Okay, I hope you understood. 5 by 2, but manually operated. Both are manually operated. Okay. Now here I am having pneumatic valve where I am having both the exhaust ports are connected with the filters and noise silencer. The supplier is always gives a clue that with respect to here in the besides this, I'll show you, there will be having a pump. Now, can you see here what type of wall is this?
Okay. 4 by 2.
4 by 2. What is the actuation?
Normally.
No. 4 by 2. Please remember 4 by 2 and 5 by 2. No normally open, no normally close. Only 4 by 2. What is the actuation now? How you are operating? Lever. This is a lever. See? With a spring return. This is a hydraulic valve. Hydraulic valve is always with a heavier compared to pneumatic. This is also 4 by 2 valve. And here we are having lever operated. Now, one more valve I am showing on the thing. What is this? Just you see. Can you see the symbol? Okay, zoom it. Zoom to the nearer. They should see that. No, here. Zoom to very nearer so that they should see the symbol on the wall. Okay, clear? Blur. Because okay, now you identify this. Can you see a wall with the 3 position? Correct, na?
Yes, ma'am.
Middle one is neutral. All the ports are neutral. Lever operated. Other side you can see a small deviations and a line also. Can you see here? Here you can see it is a 3 position. It is a 3 position. 1 position, 2nd position, again neutral, 3rd position. Can you see here? 1 position, neutral position, and another position. Okay?
Yes, ma'am.
Okay, understood? And my neutral position is middle. That's why this here I have a small line on the top of this. This is my hydraulic valve. Now you can see these ports. Ports are hose. We are going and inserting inside that. That time it will be open. Okay. This is my 4x3 wall. The middle position is neutral.
Is it a pressure regulated valve?
No, man. This is a direction control valve, man.
Ma'am, but what is that hexagonal part which is protruded behind in the end? That
This one?
hexagonal part. Yes, ma'am. Yes, ma'am.
No, this is not that pressure regulated.
Usually in pressure regulated valve, we have this kind of hexagonal protrusion. With the screw, we can adjust the spring and control the pressure, regulate the pressure. Is it kind of that?
What's your name, ma?
Ayush.
Ayush, really, I don't know this function. Actually, I will ask tomorrow, sir, and I'll come back to you, ma. I don't know properly because I don't know what is it meant for. Actually, I'm an electronic student, so I'm not much about this hydraulics. So, but whatever I know, I'll clear to you. Apart from this, if you have any doubt, tomorrow we'll ask our expert. Okay? Okay, ma'am? Okay. This I don't know, ma. I'll ask. I'll take from the sir. Okay. Now I'll show one more wall. You can see here. This is for fixing. Can you see here? Okay. This is for fixing. This base plate is for fixing. This is also a same 4x3 wall. You can see here the symbol. But it is a pneumatic wall. It's a pneumatic wall, 3 position pneumatic wall. This is 1 position, neutral position, another position. This is a 3 lever operated 3 position where the middle position is air is exhausting from A and B to outside the exhaust port. So this is my pneumatic wall. Okay, clear?
Yes.
Okay. Now I'll show one more wall you have to identify. One more wall I will show you have to identify. Focus.
Wait, give it some time.
Now you have to identify what type of wall is this, which type of, whether it is pneumatic wall or hydraulic wall. Wall, what is the wall? I'll hold here. You can be having a clear idea. So please identify the wall.
Valve. It's a pneumatic valve because there
Very
are
good.
silencers and
Very good, very good. These are exhaust ports. Please remember, exhaust ports is connected with the filters and silencer. This one is, middle one is pump. Can you see here? Numbers are both side. Okay, 1, 5, 3. And you can see here outputs. Output is numbered as 4 and 2. Correct now?
Yes, ma'am.
Okay. And control air is control. These two control air is coming from here. Correct? That control is also named as 1 and 2 and 1 and 4. Correct?
Yes, ma'am.
What is these two then? This plastic one. Can anybody imagine?
manual.
Very good. It is a manual override. The spool will be there here. Then you can see the symbol also. Here you can see the symbol. Correct, na? Here it's a 2 position 5x2 wall. Both side pneumatic control. This valve is also called as a memory valve. The control is coming from push buttons. This 3x2 valve is there now. This 3x2 valve, can you see 3x2 valve? From this control, this output, I am connecting here. This push button. With the push button, I am connecting here. Another push button, another side control. So both the side I am connecting and giving the control signal. If this my push button is went wrong, it's not working, something problem with this. The spool will be pushed by the manual override. See here. Can you see the sound? It is pushed. Okay. This is manual override. Sometimes the manufacturer will give the output other side. Sometimes it will be on the line only. Okay. Clear? I hope you are identifying the walls.
Yes, ma'am.
Okay. We'll do some more walls.
Should have offline.
Now, can you see this symbol? Can you see the symbol? This is nothing but flow control valve. This is nothing but flow control valve. Flow control has 2 ports, 1 and 2 ports. Correct? The variable, whatever you are controlling the flow is here from here. It is adjustable. Okay? It is also called restricting the flow. Okay? This is a variable controlled valve. Okay? Clear? Hello?
Yes,
Okay? All of you listening?
yes, ma'am.
Yes, ma'am.
Okay.
Ma'am, how can we check the flow rate? Means we have to separately attach the pressure gauge or something else?
Yes, we have to connect it with the gauge. Wait 1 minute, I will show you that setup also. We have to connect the gauge. Gauge will be there. Can you focus to the trainer kit? This is your gauge. This is your your manifold. Manifold means from the supply it is coming. We have to connect to the supply. From here we are going to connect. Okay. Back side of the printer kit, we have power source, power pack. How to connect with the hose? This is my hose. I have to press and pull the tipping. It is holding. See? By pulling also it is not coming out. To open that, this ring is there, na? I have to push back and pull that. This is your cylinder. I'll show once again. Pull this ring backward, then push to the, it should be straight. Push to the depth.
Okay, ma'am.
Next, it is coming to the cylinder. Here you have cylinder. I have connected a double acting cylinder here. This is my actuator. I have to connect through the walls. Then I have to connect to the ports. Okay, is it clear? Okay. Here we'll be having the base. For example, I want to remove this. I can keep it here like this. The oil will be dripped into the tray. Okay, clear? Now, focus to this side. You can see here. Here, this is a trainer kit. This is a trainer kit, which is I can make common to pneumatic or hydraulics. Okay, this is a aluminum profile where we having these slots or groove. I have to hold this wall like this. The opening will be like this. Here I have to press this blue color. I have to press. I can hold and fix. Okay, it will be fixed. For removing, press the blue color, both hand and remove. Then I am fixing here, see? Clear?
There are some clippings.
Repeat? Can I repeat? It may not be common to your side, but here in the trainer kit I am having like this. If I hold in the both the side, it will be opening. You can see this. You have to fix into the groove and I can fix here. Okay, clear? For example, I have a pneumatic valve which I am showing here. That is also this type of thing. When I press, I can insert this valve. Same trainer kit, I can use it for both the things. Okay? I have here double acting cylinder for the pneumatic. Clear? This is one. We have to open this blue color. Back side we are having like this. We have to make it horizontal. We have to make it horizontal and fix it in the groove. Okay? Tighten this. Keep on tightening, whether it is a pneumatic cylinder, whether it is hydraulic cylinder. I have a procedure, same thing. We keep on tightening, fitting this. Okay, it is fixed. Now it's very rigid. It cannot come up. Here I am having a double acting cylinder. You can see the two ports with the load. Okay, with the load we having. Back side of this, you can see a FRL unit. Can you see a pneumatic FRL unit? Here I am having, can you focus? Okay. Okay. This is my, can you see here in this? This is my, no. This is my NRV without spring. Here I want the air to flow only one side. Reverse it should not come. I used here NRV without spring. This is coming from supply. I just removed now. This is coming from the supply. It is coming to this FR. It is having a regulator. Here you can see the knob. Can you see the knob? It can be varied. This is a pressure regulator with a gauge. And also here I am having a controller which is nothing but 2 by 2. Okay? 2 by 2. This is off. This is on. Again, this has connecting to manifold. Manifold. This is connect to manifold. Air supply. Air supply is coming from here. Okay? How to connect this air supply lines? 1 minute, I'll bring the pipes. Here this is the hose pipe, hose of a hydraulic controlled thing. Okay, now this is the air pipes where I can go for the manifold. Can you see here? I have to insert. Okay, this is here we have NRV with the spring. Please remember, here this is a single one, NRV with spring. Once if I inserted into the depth, it is locking, self-locking system. I cannot pull it for. To open, you press this blue button, pull it. It is coming outside. So this is pneumatics. Okay? Now you understood where I have to put NRV with the spring, without spring. Okay, clear? Here I am having NRV with the spring. Here the NRV without spring in the near the supply. Now, you can see here I have a supply filter. What is the air service equipment? FRL. Filtered, regulated, and one more thing I told you, theoretically lubricator. But nowadays, new thing, we are not having lubricators. Olden days, olden times, we had like this setup. We had old time, we had like this setup. This is my filtered, and here this is a lubricator. We had a chamber we used to fill with the oil. Oil will be here with the Venturi method. It is sprayed. It is mixed with the air. It is to supply. But now we made self-lubricated valves. Please remember, we made self-lubricated valves. Only now we are having only F and R. No L. L will be removed because we use self-lubricated valves. This is called, I hope you are understanding. Why we have removed the lubricator? Tell me, why we removed the lubricator?
Lubricated walls.
No, lubrication was there. It is good, but we removed lubricator because outside the exhaust wall should not dissipate or does not spill the oil particles. If I am using the same setup in the hygienic condition of a milk dairy or food processing, it will spoil the outside environment also. That's why pneumatic system where we had this FRL, that will be avoided and which going for the things. Now, for example, now okay. You can see here, you can see the outer scale and inner scale. Can you see here? Outer scale is calibrated in bar. Inner scale, it is in the PSI. You know that 1 bar is equal to 1 kgf per centimeter square. That's why we are equating both the two. We are taking only PSI. Per conversion is 14.5 PSI is equal to 1 bar. That's why the outer scale is calibrated in bar. Inner side is calibrated in the PSI. Can you see here? This is the same thing in hydraulic also. Okay. Now, this is our trainer kit. So usual practice that we are not going for the high pressures. Here the scale is calibrated from 100 bar. Inner side scale is calibrated from 200 psi to 1400 psi. So this is the calibration of a gauge in the case of pneumatic and hydraulics. Okay. Now, can you identify this? Can you identify the pressure? Ball? Adjustable pressure. Adjustable pressure relief valve. Here we are going for adjusting for that. That's why I think they kept that as hexagonal. Future, we can remove that and we can put like this type of settings so that it can be moved for the things. Okay? No. Can you identify this valve? Can you identify this valve?
Solenoid operated.
No, ma. See the symbol. See the symbol.
Check valve.
Spring loaded NRV.
This is called check valve or NRV or one-way valve. The check valve or NRV with the spring. Please remember with the spring loaded. Okay, clear? I hope you're understanding. Can you identify the symbol?
Not visible clearly, ma'am.
It's not clearly visible, ma'am.
Wait, my focus. Will focus. Okay, this is called throttle valve or needle valve. It is a parallel combination of a flow control valve and NRV. On the top of this, I put a arrow mark showing that NRV on that side it is not working. Can you see?
Oh, yes, ma'am.
Okay, understood now? The difference between the flow control valve and throttle valve and check valve or NRV, both the same. It may be with a loaded with a spring or not with a spring. Okay? Clear? Now, what are these two? Okay, now I'll take one by one. What is this? Just see. Can it visible for you? It's not focusing, na? Okay, can you see?
No, ma'am.
1 minute. Focus. One minute. Okay, clear? Wait 1 minute. I will fix this on the board so that it focusing will be easy.
Mechanical roller operated valve.
Okay, mechanical roller operated valve. Okay, can you see this also?
Please fix it on the board.
Yeah, I cannot fix this one. Okay,
Keep
can you
it there.
see?
Keep it
Wait, 1 minute. Here, sometimes on the hose, we don't want to return line. That time we are fixing NRV with the spring. This is with the connecting with the hose. Here, see, this is a hose pipe only. We are connecting. Sometimes we don't want a return line. There we are connecting this NRV with the spring. Clear? Symbol?
Draw it.
Can you explain it again? Can you explain it again?
If I don't want return line, it should be blocked.
Okay.
That time we are connecting with the hose. This is with the connecting with the hose. Okay? You have it here. This side we have a hanger where we can fix it. Here we have a hanger, there we can fix it. Okay, clear? Any doubts?
No, ma'am.
Okay. Now I'll ask you one question now. Okay, after knowing everything, now I'll ask you one question. Okay, now you can see here, you told it is having a mechanical operated limit switch or roller operated. Whenever the actuator comes and presses, it will be in the on condition. Whenever the actuator removes, then it will be open condition. But what is this valve? Which valve is this? Whether it is 3/2 or 4/2 or 5/2? Can you identify? Focus. Okay. I think I will do it there. Okay, I'll do there on the thing. For example, here my actuator is coming and pressing here. So it is in the on condition. Can you see here in the on condition? As my actuator moves outside, it will be open. This is the nothing but on and off. This is also a 3/2 valve. But the exhaust is, you can see here, exhaust is kept here in the down of the roller. Here we have exhaust. Near that roller itself we have exhaust. It is a 3/2. 1, 2, 3. PAR. Everywhere we cannot connect a noise silencer and filter. That's why he left open here. Okay. This is a 3/2. Now what is the difference between these two? Focus. What is the difference between these two? Now, for example, this is a limit switch. Okay, this is having some small deviation. The purpose is here. When I fix here, okay, it comes only in the forward stroke. It should be pressing. Focus. In the forward stroke, it is pressing. It means it gives signal in one side. Returning time, it will just rolls. It will rolls. It means only way signal. This is mean when you are going for the forward or reverse, both the time signals is giving. But when the returning time, for example, I connected the two cylinders which one after another should move. After that, while going also it presses, returning time it will be not pressed, but it rolls. Okay, this is gives one side signal. This gives both the side signals. Okay, this is called limit switch or roller type operator. Okay, I will go some more cross sections. Before that, I will give a question for you. You have to answer after the. Now, if I have in my lab or in your sector 5/2 wall, okay, can I make 5/2 to 3/2? Today I'm not having any type of 3/2 wall which is having a start signal, or I want to operate with a manual. So even can I make from 5/2 to 3/2? Okay. You have to answer this after the class. When I'm going for the cross sectional, you have to answer this question. Okay.
Ma'am, can you repeat the question, please?
For example, I am having a 5/2 wall. Can I use it as a 3/2 wall? For example, this is one, I have a 5/2 wall, okay, which is having a push button or detain switch, whatever you think. Now I wanted to convert this wall into 3/2 wall. Can I do it? Can I convert this?
Yes, ma'am, we can do it.
You do? By blocking one port, output port and exhaust port or tank port.
Yes, ma'am.
Like that we can convert. Similarly, when I go for any 5/2 pneumatic control wall, this is my 5/2 both side pneumatic control wall. Correct, na? For example, I am having to control this by two push buttons. Or the signal is coming from one side with the push button. Another side, I kept near the actuator like that. That signal is coming to here. One side, I am actuating with the manually. Another side by mechanically. For example, I kept near the cylinder, this one. One side with the push button, another it goes and presses, it gives the signal. Like that, I can convert with these two as a signals, not with the push buttons. I can operate with a semi also. One side manually, another side mechanically. If I don't have this mechanical one, it is not working or something has problem, I can convert, I can remove this control, or I can design a control by putting spring also. Okay, is it clear? Is it clear that?
Yes, ma'am.
So like that, see, The same wall, it's not both side pneumatic control. One side pneumatic control, another side spring return. When control is removed, we are put the spring. Okay?
Yes, ma'am.
Okay, nobody is answering?
Yes, ma'am.
Ma'am, please explain again.
Yeah. See, for example,
Clear actually.
can I explain on the board?
Okay, ma'am, that will be better.
Okay, I'll explain on the board so I can show this in the thing. This is my double acting cylinder. This is my two exhaust or two tank ports. This is my P, this is my R, S, A, B. Correct now? I am using here both side controls. That control may be pneumatically or hydraulically, both are same. Okay? This control is coming from 3x2 valve. Clear? Now here I am connecting a manual. Spring return. Here also the control is coming from exhaust PRA. Okay, clear? Okay. Now I have written here my Z control and Y control with the two push buttons, PB1, PB2. Okay, clear? Here I given a letter wise. Okay, letter wise. Focus to the nearest. P stand for 1, R stand for 3, output is A. Here P1, 5, 3, 4, 2, Z control. What is the number Z control? 1 and 4. Y control 1 and 2. Okay? All are sleeping.
No, ma'am.
Okay. Now, here I used two push buttons. What I told before the lunch, I told when I press this, the signal goes right to wall, will be moved to the actuated position. This is a spring return. It comes back its own. Now this is signal goes here. The piston moves. Correct? This will remain in the latching condition or memory. Again, when I press this, the signal goes and gives the signal to this It is a push button. That is, it comes 6 by volt. The cylinder comes back. Now I am operating the ball, double acting cylinder, with both with manually. Now I don't want this. I will remove this. I will convert to a mechanically operated. I will convert with a limit switch. Correct? Where I have to keep this sensor? Contact sensor. I will keep here contact sensor. Correct now? My circuit is showing here. But I have to keep it that sensor here. Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
If you are not responding, I will also sleep in the lab. Not to speak out, otherwise even I will not get motivation.
It is clear, ma'am. It is clear.
Now what happens here? When I press this push button, the wall moves. It goes. This is a push button which is comes back. Here it goes and presses. This presses means here. It is going to press here. Correct now?
Yes.
Then it is after this signal gives. The air gives to the signal for the pushing. It has pushed back. The cylinder comes back. The spring return comes through this. Now I did semi. One side pressing, another side moving. Yeah?
Yes, ma'am.
Okay? This is called semi. Semi means semi-automation. I wanted to control with both continuous cycle. My punching machine is there. Once if I start, it keep on punching until unless it give the stop. Can we make with the circuit?
Yes, ma'am.
Yes, ma'am.
How to do? Tell me. Give a small hint. Can I do? It is possible with one sensor or two sensors.
Two sensors.
Where I have to keep the two sensors? Tell me. Where I have to keep the two sensors? Very good. Who told two sensors? Very good. Where I have to keep the two sensors? I have to keep the sensor here also.
One is at the source. Source.
Here sensor and here my second sensor. I should convert this to a S1, S2. Okay. Once if I start the signal, it will be keep on oscillating between the two signals. Correct now? But I have to include the start signal. I can use a detained switch. There I can connect two sensors. Is it possible? Okay. Can I show these all practicals on the trainer board? If everybody say yes, then only I'll go to trainer kit. Otherwise, I'll go home.
Yes, ma'am.
Can I show all these practicals on the trainer kit with pneumatic as well as hydraulic?
Yes, ma'am.
Yes.
Okay. Okay. Now I will give a small 5 minutes break for you, tea break. You have to come back. I'll set up all the pneumatic. The first, then second one will go for hydraulics. Okay. After doing back, again we are coming for the cross section. We are discussing, because once if I start theory, your response will be go downs. So I wanted to make the afternoon session practically. After doing practical, again we'll go back to theory. Again we'll come back. Okay. Is it okay?
Okay, ma'am.
Okay. Now you take a small 5 minutes break, have a tea and come back.
Okay.
Okay, welcome back. Welcome back here. Can you see the practical setup?
Yes, ma'am.
Okay. Now, in my lab, I have all the type of availabilities of this thing. First, if I focus here, I am having a same trainer kit with pneumatic control with the PLC. Can you see here PLC? Same thing with electro-pneumatics, basic pneumatics with the electro-pneumatics. And other side, I have hydraulics with the electro-hydraulics trainer kit. At the end of the things, can you focus that side? Can you see this side also hydraulics, which is having hydraulic trainer kit. Okay, like this I have 10 trainer kits. 10 trainer kits with us more than 10 pneumatics, 6 electro-pneumatics and 4 PLC with the SCADA, HMI and robot. All setup is with this. This is called like a mechatronics lab. This is my lab. You can see the robot. At the end, we are having Panuk robotics. At the end of this, it contains, we used to do all set of practicals as well as applications. We have application modules. Okay? No response? No response is coming? Is it okay? Now, this side also I have an electro-hydraulic trainer kit. With another side of the lab, we have electro-pneumatic trainer kit. Okay, with the PLC, we have 300, 400 PLC, 1,200 PLC, and 1,500 PLC is all with the robotic application also. So here, lab is called mechatronics lab. This lab is called mechatronics lab. Here we are conducting all the type of okay. When you comes for the offline training, we include all those things in your thing which is going to be helpful for your future. Okay? I hope so. This corona ends very soon and I can see your batch again. Okay? Now we come back to the practicals. Okay, here I connected. You can see on the little bit top you show the pipelines you can show here. I have the pipelines. My source is coming from there, from the compressor room. It is coming to this FRL. Okay, this is coming to this FRL. I have only F and R. Lubricator is removed because we have self-lubricated valves. Now it is coming to a manifold, or you can call it as a junction box, which is having many ports. We can connect it to the thing. Now I connected a 5x2 valve both side pneumatic control with the 3x2 valves. Okay, same setup I made it in the hydraulics also. Parallelly will show all the things. Now what is my concept is, here in the gauge, the measuring pressure gauge will be, I connected with the only 2 bar. Can you see here? In 2 bar is sufficient to operate without load. Okay, now I connected only 2 bar. This is my shut-off valve which is on and off. Okay, I kept on. This is my manifold. Each direction control valve needs a pump connection, isn't it? I have connected to connect. See, I connected here first pump connection for this, and also for this. Okay, I am doing here. See, for this is my start sensor. Okay, I remove. It is in the latching condition. Until unless if I not press this, it will not come back. This is called both side pneumatic control. This is called external piloted. This is called external piloted one. This is your manual overhead. Now I make semi. What I should do? I should remove one of the push button. Then I have to connect Okay. I disconnected the push button. I connected a limit switch. Can you see? It's a semi. It is operating with one side. Similarly, I connected a 5x2 wall with a double acting cylinder. Can you see here grid and switch? Single acting with a push button. Show this side. Single acting I connected. Okay, single acting. Can you see the single acting? So parallelly I'll show you everything. Single acting with 3x2 wall. First practical I showed. Now I remove I have here 6 junction. Let's say I have to remove this. I will remove this supply. I will connect to this 5x2 wall. This is direct control. This is direct control. Now this is indirect control. I hope you understood. Manually operated wall, mechanical operated wall, pneumatical operated wall. Okay? Clear? Any doubts? Any doubts? No, I'll turn this towards the hydraulic kit. I constructed a 4x2 wall with a double acting cylinder. Please turn on the camera that side.
Please unmute, ma'am. Unmute.
I'll repeat once again. So this is my power source. Power pack is back side. I'll put a photo in your group how my power packs look because it is back side of the thing. I've taken from this power line. This is a manifold. This is we are having a measure. This line is going for the source. Here it is written P. This is your T. This is A and B. A is connected to the one side of the cylinder, another side for the double acting cylinder. This is nothing but lever operated valve with a spring return. So I'll on. Okay. Okay. Now I'm owning the power pack. On. Power pack on. Okay. I'm just operating with the lever. You can see that. I have to change this position little bit. Okay. Can you see here now? On. It is with a 4x2 with a spring return. Okay, is it clear? Okay.
Ma'am, is it a lever operated one?
No. This is a 4x2 with a lever operated only, spring written. Yes, ma. Lever operated. Most probably in hydraulics we'll be having more lever operated valve only. For example, if you can see here, this is 4x3 with a lever operated only. But it is a 3 positions, it is a D10 switch. Okay, clear?
Yes, ma'am.
Anna. Okay. Stop. And pressure I limited only for 10 bar. In the hydraulics also, we always keep in safer side. I just increase the 10 bar, that's all. We can regulate. There only we have regulator on the power pack. There only we can regulate that. Okay. I hope you understood. Any doubts?
No, ma'am, no.
Today I showed you the walls and I now this is, you know that this is 5x2 wall, both side controls. Now you understood that how the push buttons I connected here and here. Correct na practically? This is a 5x2 wall with both side pneumatic control. Similarly, this is 4x2 wall with both connected with the lever operated. Similarly, can you see this one? Any similarities is there? Any similarities?
Yes, ma'am, it is similar.
Here I have solenoid valves. This is my solenoid valve. Here I am going to connect. This is one cable with a positive, another cable with a negative. Okay? This can be interchangeable, no problem. This is coil does not have any positive negative. But when you are connecting, you should take care. Okay? This is a solenoid valve. 1, 2, 3, 4, 5. 5 parts and both sides solenoid valve. The blue color, can you see here? Blue color? This is your manual override.
Okay.
Similarly, when I go for here, this is my manual override. Okay? The blue color, focus. This blue color is here in the horizontal. Can you see horizontal? That if I small screw is there, if I make vertical like this, then it will be overridden. Okay? Solenoid. Now, by seeing this, you are seeing that both the control was coming from the outside piloted, that is external. I reduced this one side control, another side spring return. Correct, na?
Yes, ma'am.
Similarly, here also. See the solenoid valve? One side solenoid, another side is spring loaded. Okay? Clear? Any doubts? Now, what are the 5 type of actuations? One is manual, one is mechanical, one is pneumatical, electrical, hydraulically, and solenoid. All the 5 type of actuation we did. Okay, clear?
Yes, ma'am.
Okay, any doubts? So far, practical and things, any doubts is there? No, tomorrow I am not, I am doing some more practicals. Now I have to set up all the things and I will show here. Focus to this side. Okay. Now here I am having a transparent modules. Can you see here some transparent modules? Okay. These are the some transparent modules. Today I am sending you some of the videos. Some videos I show given already. Some of the videos I will show how we'll operate with the power pack. Here. This is a cross-sectional views. Tomorrow I will make a video. I will show directly and also some videos I'll put with a live. So that time will be not wasted. Because tomorrow my guest faculty will come. So in between I play this video or I load it to your drive so that you can understand without wasting my time. Correct? See, these are some of the videos. See, this is NRV. You can see the live. You can see the live. NRV.
Yes.
Okay. Now here I am having 4x2 wall with a spring loaded. When I connect this practically, you can see the live oil is flowing inside. Okay. This is your so can I show like this? Because somebody should hold and somebody should on it. Come here. Hello.
Hey, wait, yeah.
Now, take this. Do. Now, welcome back again. Tomorrow I'll show some more practicals on the hydraulic transparency modules, and also some practicals on this trainer kit. Now I'll show some of the theory. We'll come back again for 10 minutes theory. After seeing the animation, we'll go back again for the practical. So now I'll share this PPT. Now I hope you understood all these cross sections. Correct, na? I hope you understood all these cross sections. See now. Here also some of the walls are there, which is particularly designed for some, like for example, it is a plate wall or different type of with the animations. I hope it is clear. See this circuit. We are controlled here with the pressure switch. It is a pneumatic one. Here we have an accumulator, air accumulator. After we are oning, accumulator will be filled. At a particular things, we'll get a signal.
Ma'am, please share the PPT.
Oh, sorry, ma, sorry. Okay. Can you see now? I will repeat again. Here also, from the thing, you can see some of the walls which is specially made, called as the bead wall. Okay. Here you can see some of the internally connected dashed lines. Okay. Like this, we can go for these animations. Here, this is a pneumatic circuit where we are connecting a limit switch with a 3x2 normally closed, and a throttle valve and air accumulator, and with the same thing 3x2 with the piloted valves or pneumatic control valves. Like this, some of the designed for to boost the weak signal. Okay, to boost the signals, it may coming from relay side or from the pressure side. One more thing I want to clear in this cross sectional, what is meant by internal piloted and outside piloted. Outside means for example, this is control which is coming from here, that is called outside control, that is called external piloted. Internal piloted means, I will show a figure. 1 minute, I will share the PPT. Basic pneumatics. Margin training, basic pneumatics, basic pneumatics. Can you see on the PPT, I have connected a circuit. Can you see here? Okay. Now you have to identify that what type of circuit this is. Okay, clear? Anybody can say that how my circuit is looking? Okay. Now I connected my pump or my compressor to a FRL unit, that is my filtered, regulated and lubricated. From that, I have connected a 2 push buttons, 3x2 normally closed. That is connected to which this one symbol. This is called shuttle valve. And then the signal is going to 5x2 valve. 5x2 both side pneumatic control valve. The another signal is coming from limit switch. Limit switch which I kept here in the near the actuator. This is the thing what I was telling, logically controlled. If I replace here dual pressure valve, by pressing both the things at a time, then only my piston will move. Here I am connected here shuttle valve. It functions like a OR. That is any one of the things. PP1 or PP2. Any one are pressing, it should operate. By chance, if it is pressing both, then also should operate. If it is actuating with the thing. The same practical, I connected logic valves, I can show you there how it is working with the logically. I'll show in the pneumatics, then you'll come back here. Okay, clear? So, I'll show the practicals after 5 minutes. Before that, I wanted to show what is meant by internal piloted ones. Can you see the figure here? Can you see the figure?
Yes, ma'am.
Okay. Now my question is here. What is that figure indicates for you? What is the figure which shows? Can you analyze?
Normally closed valve.
3x2?
Normally closed.
Normally closed.
Okay. Whether this is a pneumatic valve or hydraulic valve?
Mechanical lever operated valve, roller operated.
Roller rated, mechanically operated valve. What is this indicates? What is the meaning of this?
Integral वो क्या बोला था मैम?
Internal piloted. Internal
piloted. Yes.
Why we have to need this? This is a limit switch. Correct? Why we need internal piloted? For example, I'll show you what is the theory behind this. Now, when I take 3x2 normally closed with a push button, we are getting sufficient force to press. This force is sufficient to move the disc. Okay? Clear? If I'm not getting the force here, so much force, which cannot operate by the disc, what I can do else? I cannot go for the without any mechanical actuation. I have to actuate with a mechanical. For that, what internal piloted means, with this limit switch is small, with this force, this disc will be operated. Okay? Please observe, this is very, very important concept with respect to mechanical actuation and solenoid actuation. I am telling this. Please, all of you, 5 minutes, please concentrate. With this force, I am operating this disc. I cannot operate this main disc with this force. With this small force, I cannot operate this. So, I am operating this small disc. The air comes here through this. It is not going directly here. Air or oil comes through this. It goes here. Up to here, some narrow passage, suddenly change in the area. So you know that F is equal to P into A. I cannot do with a F. I can do with the A. So indirectly I am increasing the A by change in the cross-sectional area. Because of that, force is created. Because I cannot change P pneumatic pneumatic thing, their pressure is restricted. I cannot operate with more than 4 bar or 6 bar, or maximum with all application 8 bar. I cannot go with the more force, more pressure. So third one I am having. The third option is only A. I cannot increase force. I cannot increase the pressure. Third one, I can change the A. A means the air is not directly coming here. It is going here up to here. This will be operated with this force. Here up to here. After that, here this change in the area of cross section suddenly gives the force to operate this. Then it is called. But we are mechanically operated only. But inside air is doing the work. Correct? That's why the arrow mark shows that air is also included in this activation. With this mechanical, air is also giving the cooperation to operate indirectly. These are called internal piloted one. Okay? I hope understood. Sir, can I repeat once again?
Yes,
Ma'am,
ma'am.
repeat once again.
See, for example, this type of walls, when manually operating, we are getting more force to operate the main disc. It is operating with this force. But when I consider go for the mechanical, the actuator is moving here. It is not having so much force. But I want to operate. For this, what I should do internally, the air is indirectly I am sending from here with this force. Limit switch, this disc is operated. It moves from here to here with an arrow only. Suddenly increase in the area, then F force is equal to P into A, that indirectly creates the force to operate this main disc. This is my main disc, and suddenly it is internally piloted. So mechanical plus pneumatic operated by this. That's why the arrow mark shows like this. Okay, clear?
No, ma'am, that mechanism, how the air is moving to that place.
I will show the cross section of both. Okay, 1 minute. I will show the cross section. Both normally open, normally closed. Before this is a condition. It was like this, closed. I have shown both the one, normally open and normally closed. Both I have shown. Can you give me some time? I show the animated film also.
Yes, ma'am.
Okay. After this, I will show the animated. Yesterday, somebody is asking why every place gear pumps, na? And this is a second question. I will clear all both the things later. Now, here, first, for example, wherever I am not getting sufficient force to operate, then we have to go for the internal piloted ones. The concept here, yes ma, please tell me.
Like when we operate this lever, actually it will move downwards, right, ma'am?
Yes.
It will
Yes,
move
correct.
down.
Move downs, that time only air will insert here now. It is blocking now. Whenever the lever operated, it comes down. This also disc will go down. Air inserts from here. Air cannot insert from this side. Air has come and stopped. Air will insert when the disc is pushed down. The spring will be pressed. The push down. It inserts the air through this up to here narrow passage. Suddenly increase in the passage of this air. So it creates the force.
Okay, ma'am. Due to the spring compression,
Yes,
the
yes,
air
yes.
will
Because
be.
the limit switch will come back now. See here, the limit has come. Limit switch comes and presses now. That time the spring will be pressed. The disc will come down.
Okay, ma'am. Okay.
Okay, na? Okay. Hope I will show this animated film, ma. Okay.
And how it is called internal? How we are differentiating between the here internal and external pilot?
Correct. External means you remember for 5x2 wall I connected this output to 5x2 wall. This I am doing externally. I am giving the signal. You focus to that this thing. Focus to the trainer kit. Now, this is my external pilot signal given. So, this is external signal I am giving through from push button to 530 watt. I am giving outside. Internal pilot means after operating the limit switch, this gives this to operate, that this move from the inside this. That is internally, air is also helping. Right now? I hope you are understanding. Somebody asked me external and internal.
Ma'am, just please repeat what you said. No, just now. Just please.
See, this is the signal which is coming from another push button. The signal is coming from outside. Okay?
Yes.
Do from outside means it is external. I want to do from internal only, then that air, whatever this air is coming now, that I will do internally without pressing the small disc, that air goes and operate the main disc. That is internal pilot. Okay?
But ma'am, actually in the pneumatic one, there also that air is only helping, no, in the inside mechanism to work. So here that pneumatic one, there also it is that external air is only helping, no?
Correct, ma. You just now see, for example, you just observe this again slide. I have here, this is my pump port. This is my pump port, output port and exhaust. Okay. This is my pump, output and exhaust. This is my main valve. Okay. The external should come from here, then it will be moved. External force. It should come on this disc to operate this one. Correct, na? But I am not doing that. To operate here, I am not connected here. I have connected a mechanism that here a limit switch is there. This is connected to a small disc. The air will go first this side because it is blocked both the side here. With this force, this disc is operated. This is indirectly operating to the main disc. But my main ports are pump, output and exhaust. Correct, na? Air is only doing. But now air, how it is moving with the mechanical? With the mechanical, air is only going in a indirectly pushing the push button. Disc.
Yes.
Okay.
Yes,
now, for example, I will tell you, this is only one point you concentrate, you will understand. For example, this is a mechanical. Now you imagine this is my solenoid.
We are taking the help of two things. We are taking the help of that mechanical switch also, and the fluid internal, the fluid that is moving, the fluid pressure also we are using, which is going through the valve, which is the main transfer fluid.
Yes, ma. Exactly, ma. See, mechanical plus pneumatic or hydraulic, whatever it is. It is maybe air or oil.
Here we are using the same fluid which we are transferring it through that of valve. In the other one, we are using the different sort of fluid.
Correct, ma. This is the pump. This air only I am taking here as an internal pilot.
Correct, ma'am.
Correct, na? Understood? Now I'll give you one very good concept of solenoid was to operate this disc. How many number of turns we needed to create that much force? Correct, na? If I extend this disc to outside, then I coiled. to that, it needs number of turns is more to create so much force. When I operate for this, when a number of coils operated to this, it will be cost reduces, size reduces, number of turns also reduces.
Yes, sir. Yes.
So all the solenoid valves are internally piloted. Understood? For example, when I go for these solenoid valves, see, when I go for these solenoid valves, can you see the size of the valve is reduced so much? Can you a small, like a bread piece, it is reduced. If I wanted to go in this method, if I wanted to go in the same method, which is normally having, this may be extended and the spool may be extended and it is winded with a coil, then the coil size will be bigger. Cost increases, size increases, and energy also waste. Instead of that, when I can reduce this valve to so much, I have to make a design for that to reduce my coil also. Correct, no? Yes, nowadays we are going for the compact one. Nowadays we are getting modular valves. This is a one piece, you think like bread pieces. It is connected. Single solenoid is connected with all the valves and single port with the pump and all the two outputs. That are modular valves. So now then we can imagine. So the compactness is coming very small. It is becoming very compact. We cannot think, for example, if I consider this 5x2 valve, the size, you see the size, this is my pneumatic valve. You can imagine that hydraulic valve bigger because we need that hydraulic. But in pneumatics, we have lot of things we are doing to reduce the size. By the valve has reduced so much, I cannot imagine the solenoid valves will operate with a direct method. I should go indirect method. For example, this spool, this metal part is extended further and I am actuating with a solenoid. That number of turns will be directly proportional to voltage. Like that I can imagine. Then voltage level also increases, size also increases, then number of turns also with respect to the cost increases. Like that we cannot imagine. We have to design such a way that if I design here the size is reduced because indirectly I am doing. Indirectly, all pilot valves are internally piloted. That's why the size is reduced. Otherwise we cannot imagine. Okay, I hope you understood.
Yes, ma'am.
All the solenoid valves are must and should be internally piloted to reduce the size, reduce the cost, reduce the to make the modular valves future. Okay. Okay. I hope everybody understood. Shall I repeat?
No, ma'am.
थोड़ा हिंदी में बताऊं? अगर किसी को प्रॉब्लम है तो मैं हिंदी में थोड़ा बताऊं?
नो प्रॉब्लम.
नो प्रॉब्लम, थोड़ा हिंदी में बोल देती हूँ. तो थोड़ा सा no, अभी क्या होता है, समझिए कि मैंने ये मेरा मेन डिस्क है. मैं इसको ऑपरेट करने के लिए क्या करती हूँ, इसको थोड़ा सा मेटल पार्ट को स्पूल, ये तो डिस्क ऑपरेटेड है, समझिए कि आप स्पूल ऑपरेटेड है, इसको आगे तक थोड़ा सा एक्सटेंड करके इस कॉइल को मैं क्या करती हूँ, समझिए कि मेरा ये स्पूल है, इसको मैं लपेट के इसको एक्साइटेशन कर देती हूँ. ये जब एक्साइटेशन है ये मैग्नेट हो जाएगा. ये जो मैं हाथ से करती हूँ मैग्नेटाइजिंग के पुल एंड पुश हो जाएगा. इसको मैं पुल एंड पुश करने के लिए इस जो फोर्स दैट इज डायरेक्टली प्रोपोर्शनल टू वोल्टेज, दैट डायरेक्टली प्रोपोर्शनल टू नंबर ऑफ टर्न्स. ऐसा हम लोगों का थियरी का वजह से अभी मैं ये इतना बड़ा डिस्क को मूव करने के लिए फोर्स भी ज्यादा चाहिए, नंबर ऑफ टर्न्स भी ज्यादा चाहिए. इसके बदले में मैं इंटरनल कर लेती हूँ. तो ये मेरा इंटरनल इसका स्पूल समझिए, इसको मैं नंबर ऑफ टर्न्स करूंगी तो साइज कम हो जाएगा, नंबर ऑफ टर्न्स कम हो जाएगा, जिसको हम देने वाले वोल्टेज भी कम हो जाएगा. इसलिए ऐसा हम लोग करते हैं. मैं इसको आपको एक फिगर बताती हूँ. इसके इस पीपीटी के बाद मैं सोलेनॉइड वाल्व्स का बताती हूँ, तब आपको समझ सकते हैं कि इंटरनल पायलट करने से बहुत सारा फायदा हो सकता है. साइज कम हो जाएगा, कास्ट कम हो जाएगा और आगे जाके आपको मॉड्यूलर वाल्व करने के में भी आपको सेम हो जाता है। यहाँ पे ऐसा वाला सेम वॉल्स कनेक्ट करके सोलिनॉइड वॉल को ये करके एक साथ एनर्जाइज करके बहुत सारा कंट्रोल कर लेते हैं हम लोग। इसके हिसाब से हम लोगों को ये समझना चाहिए आने वाला सारे सोलिनॉइड वॉल्स इंटरनल पायलटेड है। इंटरनल पायलटेड से ही हम लोग करते हैं। आजकल डायरेक्ट कंट्रोल सोलिनॉइड वॉल नहीं है, इंटरनल कंट्रोल है। इसके लिए हम लोग ये इस कॉन्सेप्ट को लेके सोलिनॉइड वॉल पे मैं आपको दिखाने की कोशिश किया। अभी मैं आपको प्रैक्टिकल दिखाती हूँ जिसमें हम हाउ वी आर गोइंग फॉर लॉजिकली कंट्रोलिंग a machine with operated by the two hands or a machine operated from the two sides, two different ends with logically dual pressure valve and shuttle valve. Okay. Now here on the trainer board, I connected with the same circuit with the logical valves that is called as a dual valve and shuttle valve. You can see here, this is my dual pressure valve or two pressure valve, or you can call it as a and valve. And means both, you and me, both. Similarly, when I look wise, here dual pressure valve and function and or function or shuttle valve both look like same, but I connected here now dual pressure valve. My concept is here, when both the signal comes, then only the piston should move. See, I connected here, it's not moving. When I connected here, safety. When I connect both with the pushing this. Okay, I hope you understood this thing. This is called safety. For example, a punching machine will be having, unfortunately, the hand may go and damage the things. That's why, for safety precautions, to engage both hands, it will be operated like this. Okay, clear? I hope this is clear. Now I connect another logical valve, which is called shuttle valve. I have to close the supply, just disconnect this. There is no direction is not there. You can give it to any one of the things. Two push button signals is given to any one of the things. So I connected here. Now you see, this is functioning like or shuttle valve. Both. Okay. Okay. This is the concept of shuttle valve. This is any one or both. Okay. I hope this you understood. Clear? Any
Ma'am,
doubts?
what is the name of previous valve?
Dual pressure valve. That is a safety valve. It functions as a AND. Dual pressure valve or two pressure valve are AND. And usually they will not say in the industry. They will say two pressure valve. Okay. This is called shuttle valve. Shuttle valve work as a OR function. Dual pressure valve or two pressure valve act as a AND function. Okay. Clear? I hope you understood.
Yes.
No.
Excuse me, ma'am.
Yes, ma'am.
Where can we find a solenoid valve used in basically oil and gas industry?
Solenoid valves.
Solenoid valve, yes.
Please focus to this side. Focus to this side. See, I already have a setup here. Can you see here in this side? Now here, last week I had a PLC course. For this I connected. Can you see here? I connected a read sensor and also to a solenoid valve.
Yes, ma'am.
This type of applications, when I wanted to connect here to the PLC, I will go for solenoid only because it is having an application with the electricity with the wall. Wherever, for example, I will tell you a good example. Today I am going to operate a metro train, okay, or any Volvo bus or whatever the things. I want to control the door, light, AC, and also the controlling of the motor or wiper. I wanted to combine this electricity from pneumatics. That time we want a solenoid box and also proximity sensors because he is sitting away from the door, he cannot see. So proximity sensors are one we can control through electricity. Contact sensor means we are not getting the signal to the for the sequential order, one after another. I hope you understood.
Eddy currents, right?
See, for example, today our world is moving towards the automation. Automation is only happens with the fully controlled. The fully controlled they used to do with here, but here you cannot extend this control. This is my control, isn't it? This is my controlled thing. I cannot extend. Now what they made is 1 minute. I'll just focus this. What in the future we did here? We separated the wall with the electrical control. We are giving from the push buttons. Push button in the panel. It is near the driver seat. By controlling the push buttons, we are controlling the solenoid valve. Here you can see here my push button and activation was nearer. In electro-pneumatics and in electro-hydraulics, we separated the valve and controls separately. Push button separately and valve separately. Okay? I hope you understood.
Ma'am,
Tell me, ma'am.
ma'am, in oil and gas industry, these solenoid valves are used like we have control panels in engines. So if the speed of engine is very high or there are temperatures and pressure sensors, so if the temperature is very high, then that control panel will send the signal to the solenoid and then solenoid will shut off the engine. So this
Very
is
good.
how it will be.
Yes. See, last week what we did is some electro-pneumatics with the PLC for this Ongc only. We did for the instrumentation people. Okay? Last 2 weeks back. That time we have to show for them, we are connected a solenoid valves and to a actuator, different type of sensors like temperature sensors, light sensors, optical sensor, inductive sensor, and also capacitive sensors. With a different type of sensors, how the signals is going to solenoid valves. From that signals, how the my actuator will be controlled. Like that will be in the future also. We'll be having, it's only not pure pneumatic. Pure pneumatic, pure hydraulics is now, it's gone. It is going with the combination of all these electro-hydraulics and electro-pneumatic valves or solenoid valves. That signals is going to the PLC. From PLC, it is going to the HMI, where he can change these parameters. Without not going for the field, sitting in a place, he can operate with the HMI. Then that everything will be viewed or controlled through a SCADA. Like that, the process is going with the control of these proximity sensors and solenoid valves. Lot of things we can do. Today, the world is IoT, Internet of Things. Internet of Things, you may having different type of sensors which gives the signal for different. For example, I am a farmer. I want to know the what is that soil property, which crop is needed for me to get the more crop or more production. That type I will ask from here through internet to the advisor or a good some institute, so that he can get the feedback. He can show the soil moisture. We have the moisture things. We have different type of sensors which gives for the improvement of the technology. Okay. Now after this training, when you go to your field of working, that time you will get some of the more information.
Ma'am, please tell something about PLC, SCADA and all, please. Just brief.
Brief means how I have to brief. I have to show some videos which is interconnected to all those things. Correct, na?
Yeah, but
Now,
just the sequence of how what is the use of what this PLC, the SCADA and all. And
okay. Actually, you are asking a question where we have 5 days course. You are asking in 5 minutes. PLC is really I'm telling, PLC is a ocean. Ocean means you have to keep on working, and these people, the Siemens, whatever the Fanuc or Allen Bradley or whatever the PLC people are, Honeywell, so many Mitsubishi, Fanuc, so many industry people, what they are doing, like our cell phones, like Samsung, Nokia, MI, so many, like we have phone same setup, but we are given the option such a way that we can go for easy to work. Mechanically, hydraulic and pneumatics is very difficult to work. If same thing when I wanted to control PLC, it is very easy, because once the setup hardwiring is done, only you have to control the things. That is done by the PLC. Only, for example, I connected here, some pipe is loose, air pipe is loose or hose pipe is loose with oil. After I am on, that suddenly burst out. But if I connect to a PLC, before going to the thing, the indicators or the proximity sensors, you would get an indication that something fault or line is not flowing. You can see the ladder diagram itself. There only you can rectify what is the problem in the field. Here, every wire I have to connect and see. For example, if I connected so many wires in the PLC to the hardwiring, small break in the wire or small hose pipe leakage is there, I cannot go and see in the field. But same thing, I can sitting in the PC, I can see that ladder diagram. There will be a designation or addresses for the each and every sensors, each and every push buttons with the NO contact and NC contacts. After checking there, if it is everything okay, the green light comes on the PC, that is on the ladder diagram, so that we can rectify it is the closed loop or it is fully what we say that it is okay. Then only we'll operate. Otherwise, PLC people also given if something problem with the inputs and output, suddenly it goes to off mode. Off mode it goes means that time we can understand that something problem in the hardwiring. Then we'll go and check again. We'll rectify in the software where the problem. If the sensor is not working, till that air will not go or the light will not go. There will go exactly and will rectify. In like this, without anything, software, we can identify where the fault will be. Fault and troubleshooting is very, very easy in PLC than compared to pneumatic and hydraulics. And hydraulics, what is the one thing see every field is have its own applications, like whatever the advantages and disadvantages. But which place you are using for where you are playing, that is very, very important. Today I am controlling the food processing industry by sitting here. I had to control the temperature. I want to control the flow. I want to see the hygienic condition. It is packing number, whether it's the sensors are giving, all the conveyor is good working, or the function of a robotic is placing properly. So many inputs are there. Then I need a PLC. So many inputs and so many outputs. For example, I have here JCB, only one pipe is there. It is moving only one function. there you go for the hydraulics. That will be easy for you to high load and high pressure. Okay, I hope you are understanding. Okay, clear?
Ma'am, can I know the mechanism of bleed valve? Do you have bleed valve? Can I see it?
Bleed valve. You have bleed valve in your sector? You have bleed valve?
Yes, ma'am. In gas turbine, there is a bleed valve which operates.
Okay. 1 minute. I'll just show you. This my PPT has.
It also runs in with the help of solenoid.
Okay. Me just now I showed you. One minute, pa. Just search out, but I had this.
Means like in your lab it is
Can
not
you
there,
see?
ma'am. In your lab it is not there.
No, ma, it's not there.
Actually,
Here, you can see here. In this one, it is a pneumatical only, bleed walls. It
Please share the
provides.
PPT, ma'am.
Yeah. I shared already, ma. I shared already. You can go and see in Northern training walls. Yesterday I shared all the material.
Okay, ma'am.
In this, you can see that a dotted lines. It is an internal piloted. Can you see a dotted line?
Ma'am, you didn't share the PPT in present video.
Okay. 1 minute. You can see here bleed walls. Here you can see the dotted lines. It is controlled to the solenoids also. From here, the air is supplied to a internal piloted. Correct, na? But the you give me some time. This bleeder wall, whatever way I have a material or in the internet, I will search and I will give you animated so that you can understand better. Okay?
Okay, ma'am.
Tomorrow I'll come back. I will search out this, but here it's not so clear. I will show a bleed wall which is controlled by the solenoid walls, and as you told, the signals are coming from where? For this bleed wall, the signals are coming from
DCS.
Okay, DCS. Okay, DCS. Okay, ma. I will see and search out, ma. Give me for some time. I will come back to you.
Okay, ma'am. No issue.
Okay. Now, this is the one which I wanted to show. Here. This is my one of the solenoid valves I'll show here, 5/2 pneumatic control.
Like, ma'am, from Mark 6, the commands will be given to the bleed valve before starting the gas turbine.
Okay.
The bleed valve always should be opened. If it is not in open position, the gas turbine will not allow to start. Like it is a sensor which was controlled by Mark 6 in DCS.
Okay. Okay, ma. It is there, ma. Like that only the controls will come. For example, if you are going for the future sectors, nobody wanted to operate with manually. All nowadays they wanted to control the things, everything by the like for us fast working is needed. Troubleshooting and maintenance. PLC have minimum maintenance and troubleshooting is very fast. So the people prefer future also for the fast production or fast thing, because nowadays you cannot operate this with going to the field and you are operating. For example, if I say the example of this GAIL, Gas Authority of India Limited, they laid the pipelines, correct now? They have sensors. They have a sensor which the combination of the sensors is with the gas contents. Whenever there is a leakage, this gives the signal to the control room. They will go there and they will rectify that particular valve section. Okay. Similarly, when they have these panels, control panels in the, for example, now pipeline is laid from Gujarat to Loni, Delhi, that longest pipeline. There, how to check this, whatever the regulation, they will go in helicopter. They will take a signals from all the sensors by sitting in helicopter. You can imagine the kilometers signals are coming from the sensors. Like that, our sensors are working with this very effectively with the internet. Okay, so like this, we can go imagine for the future fully with the automation. That is included with the internet. That is the whatever is the today's generation is coming with the IoT and artificial intelligence. With the artificial intelligence, you can go and predict the things also. One minute, I will unmute somebody. Okay. Now here I am showing a 5x2 wall with all the whatever the ports are in the downside. You can see a P is connected to B side, S is blocked, A is connected to R. I will show one more thing, wall which is differently constructed. You can see here. This is also 5x2 wall with a manual override. Can you see? Now the output ports is on the top. This is my spool. This is my spool. These two black colors are manual override. Okay. These two black colors are manual override. Now my pump is connected to B side. That time my signal is coming from Y. Now second one, when I connected to the other side signal, the spool is moving. You can see both of them are together. I will just make a minimizing. Okay. Are you able to see both the actuations from Y side and Z side? This is a whole unit. The spool is moving. Whole unit spool is moving. For the solenoid was same thing. You have to imagine. You have to extend this and you have to coil the things. With making a magnetization by pulling and pushing, you can make this. Okay, magnetizing and demagnetizing with the electricity. So that time we can make it as a electromagnets and controlling the spool movement. Whatever we are doing by the pneumatic air, it is controlled by the solenoid valves. Okay.
Which PPT is it you are talking about?
Whether it is a pneumatic controlled, this is my pneumatic control. This is the valve I am showing. Okay. That same thing, whatever the spool is there, that as can be extended further outside from the wall. Yep. It can be solenoid.
Ma'am, the PPT is not loaded actually. It is showing something else. It is showing some other slide.
Can you see now on the thing? Okay. Now this is the wall which is having the output ports on the top. Pump and exhaust is downside. Controls is coming from here. This is the whole spool is moving. Okay. This is our manual override. Clear? Hello? Is it clear?
Yes, ma'am. Yes, ma'am.
Okay, now you can see here both the actuation from Y side and Z side. with the manual override. This is a cross section of the 5x2 wall with the both side pneumatically or hydraulically actuated with the manual override. Symbols also you can see here. This is a symbol for manual override. Okay.
Yes, got it.
Okay. Now can we revise from morning what all the things we done today? Now today we started with the symbols. First symbols identification, then with the cross section, how to identify 2x2, 3x2, 4x2, 5x2 with a different position, 4x3, 5x3 like that. Again we went for some practicals in the pneumatic as well as hydraulics. Correct na? Tomorrow I will demonstrate more hydraulic practicals because tomorrow I'll get the time, I'll make a video and I'll upload to the things, because by connecting the hose pipes, it is not so easy in the short time period. In hydraulics, I have to remove the hose pipes, I have to connect, backside I have to connect, I need somebody's help. So tomorrow I will do, when my guest faculty is taking the class, I will connect all the things, I will show simultaneously in the break time. Okay. Now here, till today, what we completed is very, very important as per your working conditions. If you don't know the theory also, by doing and tracing the walls and connections, you can do lot of things in your things. Okay? I hope you understood. And logical gates also, logical walls also, we are little bit work. NRV, flow control wall, and also throttle wall. And we went for what extra we did? Some of I wanted to show the simulation. Now, are you sitting for some half an hour more? I will show simulation on the fluid sim.
No problem.
No problem, na? If you want, you
problem.
take 5 minutes break. 5 minutes break you take. Again, come back. I will show the fluid sim with you can operate and you can enjoy the thing. Okay? Here, I will do a small 5 minutes break. I will come back again with the fluid sim. We'll work for up to some. Now, what is the time? 5:30 will work. Then we can leave the things, because yesterday I couldn't complete the many of the things. So today I have to complete all this portion. Okay? Can you come back after 5 minutes? 5 o'clock we'll start again class. Okay? Okay, ma'am. Welcome back. Now, I have shared you the material, which is this one folder. I hope everyone is got. Okay? No. You got it or not? Hello?
We got it, ma'am.
Got it, ma'am.
Okay, now go into fluid sim P. I will show first pneumatics, then I'll go back to hydraulics. First demo with the hydraulics. Fluid sim H stand for hydraulics. Fluid sim P stand for pneumatics. You are asked if the training would be in the office mode. It would be a very much interesting. That is offline, na? Yeah. Offline, but I will expect again very soon. You people are coming again to our institute and doing hands-on practice, but it is not possible now because of Corona. I will go to fluid swim demo. You double click. Go to bin. Please remember bin dustbin. Okay, bin. Then you go for fluid sim demo. This I have given a demo version because I have a same thing which a license version. I cannot share that one. So demo one I am sharing. So go to the demo, double click. Okay. Okay. Now, shall I show once again? Okay. Now, after going for fluid sim demo, then I'll go for file. Whatever you are working with the word, na, same thing, file. I will take a new folder. When I take a new folder, you'll get a page. This is my total view of the library. That is my components. You can go for here. All different type of component, which includes pneumatics and electro-pneumatics. Similarly, fluid sim H contains hydraulics and electro-hydraulic. Both combined together it is given. So now what you have to do is, you have to concentrate here and you have to learn. Now it is a some demo 3, third version it is. Fifth version it is in the license version. But little bit more advanced they are done, but this is okay for learning purpose. This is okay. Whenever you come here, you can go for this online license version, but it is now you can go for here demo version only. This is only we can give for you. This is my compressor. This is my air service equipment. This is simplified form. This is full form. This is pressure controlled valve with the manometer. This is single acting cylinder with another side spring loaded, double acting cylinder, like that everything, all the cylinders here included. Similarly, I have a 2x2 wall, 3x2 wall, 4x2, 5x2, shuttle wall, quick exhaust wall, dual pressure wall, needle wall or throttle wall. Here also I have pressure. If we go to near that, it will show the full name. Pressure sequence valve, adjustable vacuum actuator valve, time delay valve, time delay valve with normally closed, with normally open, piloted, manometer, R gauge, whatever, suckers, suction cups. Suction cups is there, na? You know, I think suction cups will be fixing on the thing. It need not to have a thing. Similarly, I'll go for, these are all different type of applications, counter, analog things. And also if you go down, you will get electro-pneumatics with the solenoid valves, relay controls, proximity sensors. Everything we can add. Now we'll go for a basic simple thing. You know that My source is must and should. I will click and drag here. Okay. I'll take a single acting cylinder. Click and drag here. I will take a 4 by whatever the valve is there. You can take. I'll take a 3 by 2 valve. That you can with the arrow also you can shift it. Okay. Now I have to connect the ports. Now I know this output port is connected to upper part of this wall. This I have to connect here. I want actuation. Wall is connected, but actuation I need. I will select this. It will go back. Okay. I'll select this wall. Go right click. Go for properties. There I have a dialog box with left actuation and right actuation. Here if I click here, so many manual operated. If I go mechanical, we have all manual or mechanical actuation. If I go for pneumatic or hydraulic, you have solenoid valves, piloted solenoid valves. Similarly, here also same spring written, piloted, manual, mechanical, and also electrical or hydraulic one. No difference, but here I was more familiar with the pneumatics. That's why I'm showing here. Now I have to select here manual with the spring written. Correct, na? Okay. I've selected a 3 by 2 wall with one side manual, another side spring written. After this, I have to go for simulation. Go here on this start. Okay. It shows that open connection. What is the open connection? You can see here a mark on this port because third port I have not connected to a tank or exhaust. So, okay. Then it will asking, can I simulate anyway? No, I don't want to simulate like that. But in simulation, I will say, yes, I'm not going to connect the exhaust or something because it is a software. Na? So I will not go for this, but I will show the procedure. So go for this port, right click, properties. Here you will get the connection, designation 3, terminators. Here you will ask flow or pressure. So I'll go for here to here, click. You will get a block, silencer, exhaust port with the thing and the silencer. So I will take a exhaust. Okay. So it is connected. Now if I simulate, it will get line. Now you can see here, dark blue is the input, light blue is the output. Go on simulate here. You can see this in the actuated position. When I leave my hand, it comes back. Okay. This is my single acting cylinder with the 3 by 2 normally closed. Okay. I hope you understood the steps. Today, all of you should go and see in the simulations, hydraulic or pneumatics, whatever you have, the small circuits you put. Okay. Otherwise, today I will give some circuits. Today, after going home, I will share you some of the circuits. You put it on the software, you connect it and give simulation. You see what is the problem. By practicing only, you will get this thing. Okay. Similarly, I will go to stop mode. I will take a double acting cylinder. I will take a 4 by 2 wall. Okay. Now I'll connect here the ports. Whenever it goes to that port, it becomes green. I will take here. Go for properties. Go for Now I'll give simulation. You can see both are connected to a pump. Whenever I press here, see, okay, clear? I will do similarly with the memory condition. You will understand that time what is the thing. I will connect here. So it will not operate in the on mode. So I have to go to in stop mode. Okay, I will take a double acting cylinder. I will take a 5x2 wall. I will take a 3x2 normally close. I'll go for this actuation, go for properties, go for manual, okay, and spring return, okay, and I'll take a compressor here. I will connect from pump to compressor. Okay, now here also I have to go for, I've given here 3x2. I'll select this, copy, paste. Okay, then I'll take this, go for properties, go for pneumatic control. Line is showing now, that is pneumatic control. Here also pneumatic control valve. Both are pneumatic control. So I'll connect here this port properties. Line is selected, cancel. So I should select the 3 properties. Go for again 5. Both exhausts are connected. Okay, I connected all the things. I will go for simulation. You can see the live lines. Live line means from the pump, it has come to 1, it has stopped. Here it also it has come, and here to supply lines are there. The pump is connected to 2 sides. That's why here up to here the supply line has come. So I'll operate plus it is in the memory condition. Okay, or latching condition. Until unless if I press here, it will come back. Okay, clear? Now I'll show here with a semi. Semi means I will take push button and another limit switch I connect here. So for the same circuit, I will just stop here. I will delete this. I will take one more 3x2 for actuation and go for properties. Sorry. I will go for mechanical with a spring return. Now I have to connect another side, but here the exhaust port. Okay. Now the limit switch is here, but the software does not know where it has kept. For that you have to go to distance rule. Please note this step. Distance rule, you have to bring it and keep it here, which up to what distance it has should be. Now right click, go for properties. It shows that my sensor, yes, I kept here in the mm. I go for centimeters or mm, no problem. Centimeters, okay. Mm also okay. We'll see what happens. It has come here. Okay. I wanted this to go with the centimeters. Right click, go for properties. Then I will indicate here. Okay. See, the sensor has come up to here. Understood? You have to keep like this. Now this sensor I have to name here. Go for properties. Name it as yes. Contact sensor. This is now contact sensor. I kept here, but on the scale I've kept here. On the with the designation that yes. Now go for simulation. See, automatically it is coming down. See, you can see I've taken my hand, it goes plus and come back. Okay, we can see like this, any type of things we can operate, and you can see the things. I will show like this more number of practicals on the hydraulics also. Tomorrow I will show the simulation and as well as more practicals on the transparency and also on the things. Any doubts regarding today's class? So all of you please respond. Hello?
Ma'am.
Any doubts? Yes, ma. Yes, please.
How do you know that the 10 centimeter will be the stroke moment?
In the software, the 10 centimeter is the stroke length. In the software, if you go for this more properties, here they will give the information. According to the go to help, it will give that more information about the things. Now in my simulation software, that distance rule is only 10 centimeter.
Acha, if I keep it 15 centimeter, it wouldn't have operated.
No. That scale itself is having so much length. You can give for 10 centimeter or 5 centimeter. It will be 1 minute. I'll just show you that thing. Okay. 1 minute. I will show with the practical. Okay. Now I'll go here. I will go for the stop mode. Stop mode. Okay. Here, by using this, I'll go click on this, go for properties. There I will make it as a 5. Okay. So you can see the sensor has come to middle. Okay.
Yes.
So you simulate. See, after that it will come back. Even though the scale is there, the sensor wherever you kept, it will come back there. Okay. I hope you understood.
Means
For example,
wherever if we keep the sensor, it will stop there only and it will move back.
yeah, that is the work of the sensor. That's why we call it as a contact sensor or proximity sensor. Wherever we precise now, that place itself, it should sense and it should come back. Okay, clear?
Okay, ma'am.
Okay, na? Because, for example, I kept a contact sensor in the distance of 2 centimeter. Then after touching that, it will come back because this gives the signal to return. This gives the signal to return. This is a sensor.
Understood.
When it is pressed, the signal will come back and it will move to the backward.
Like entirely the simulation software is having a maximum of 10 centimeters only. A scale of 10
In
centimeters.
this software, the sensor is kept up to 10 centimeter only.
Okay, ma'am. Understood.
Okay. I hope you understood this. Today, I am sharing some of the exercises. All of you, actually, when you are in the offline training, last day we used to give you test. Okay. Now today I am giving you some of the circuits you had to simulate and you had to send in the WhatsApp. Then only I will understand that you are understood this software and you are working on that. I will give two circuits and pneumatics and hydraulics. Both you have to work out and you have to learn. Then you have to come back and show it to him in the WhatsApp group. Okay? Is it
Okay,
working?
ma'am.
We'll see how many of the people you will respond. I will give as soon as I'll go home, I'll give some circuits. It may be whatever I have done, let it that only you do it. But totally I have 13 members. Okay? All the 13 things has to come from their WhatsApp thing. Okay? Clear? You should not copy. Okay. Okay, shall I complete the session today or shall I continue some more examples? See here, you wanted to slow down the motion. See, one more thing I will tell you.
Ma'am,
If I want to...
ma'am, there is a timer running at the bottom of this software. What is it?
Here, na? Correct.
What is about? What is it about?
That is, we are working. Okay, we are working on that. Now, it was in the on condition. When I stop the simulation, it has stopped. Okay. Now, for example, in between, I want to slow down the motion of the piston. You put a flow control valve here. You insert here. Or I want to see the line pressure. You insert a line pressure. A gauge is there. That you can insert. The manometer. You insert and show here. Okay. Here. Or I wanted to make the thing. Only forward should be very fast. Return should be very slow. Then put a throttle valve. Or control here with the two push buttons. Control the signal like I showed with a dual pressure valve and shuttle valve. You insert somewhere and show me the circuits. Something you do which is so for you also some creative. You work out on the software. If you get any doubt at any time, you can ask me after the class also. No problem. On WhatsApp. On WhatsApp you have to answer me. After that, if you don't know anything, please tell me. I will help you in the afternoon or after going home also.
Ma'am, which folder is it?
It is Fluid Sim FSH FSP. Whatever I yesterday showed, no, that same thing.
We'll send the
Ma'am, in FSP3 demo, there is a bin. After bin, where we have to go?
You double click.
Yes, ma'am.
You go to in the middle. FS demo.
FS demo.
Sure.
Yes, ma'am. FSP demo.
Here. You are going. Wait, man. Wait. I'll show you, ma. Once again, I'll show you. How to go for the path, I will show you. See, for example, go back here. See, for example, you went for this fluid sim P, double click.
Don't give tough.
Okay.
Ma'am, don't give tough circuits.
Bin, you have to go for bin. Bin, then you go for fluid sim. FSP demo. Festo. It is written, see?
application.
Above the help, it is going for FSP demo application. Okay, clear?
Ma'am, don't give tough
circuit. Okay, ma. See here also, can you see back? You go back. Go to BPM6C. Double click. See, you can see here some of the animations, some of the exercises. Okay. Here some material also is there. You can see the animation also. See that steps also given. I hope you are understanding.
We are not able to see that.
Yeah. You go to here first. You can see a BP6C. Double click and you can see some of the material is there here. Double acting cylinder. But when they work out, they will come. They will come to know.
This.
Wait, I'll just see this. Okay. Shall I continue or else shall I stop, ma?
Continue, ma'am.
Continue. Okay. One minute, I'll just see that some of the things are in this also. Some presentation also I've given. Valves, symbols, safety. Here also you can see some of the, whichever it is very needed for you, that PPT is also given according to the industry side.
Ma'am, in that demo version, some of the models are missing. Is it like single acting spring back cylinder is not there?
It's not there, huh? 1 minute, 1 minute. It's there, ma.
Ma'am, but the one which you shared, I cannot find that.
Wait, 1 minute, 1 minute.
Maybe it is a thing.
No. Wait. You go to fluid sim demo. Can you see? Can you see screen? Okay. I opened. Bin I went. Now here I went to fluid FSP demo. Okay. Clear?
Yes,
you can see here single acting.
Yes,
Single acting cylinder. Single acting cylinder. Go for a new. Go for a file. New. I can click and drag. Single acting cylinder. Single acting cylinder with other side spring loaded. Double acting cylinder. Is it clear? Can you see? You are getting or not, ma? You cannot find. This is a variable thing, sir. It should be now. You should get it. See, other people try out. Other people.
Ma'am, in single acting cylinder, like it is not showing spring. It is asking the F value. So shall I put the F value?
You are working with the whatever I am showing, same thing, na?
Yes, ma'am. Same thing.
It is there, no single acting. See, it's not showing anything.
Ma'am, wait, I'll share you the photograph.
Go back.
Stop sharing.
You are sending with the WhatsApp, ma?
Yes, ma'am.
Okay.
Ma'am, I sent you one photograph.
Okay.
If I drag and drop this single acting cylinder, it is asking for this F value. F value is equal to 0.
No, you went for different software. It is not looking like this. 1 minute, ma. Just check out. Well, not this, I think. You give me full photo of this, ma. I wanted to see the which version you got. Fluid Sim 3 or 4 or 5.
Ma'am, 3.5.2.0. This version.
No. Don't go to that. Only 3 you go, ma. It's not opening. Hello?
Yes, ma'am.
You will do one thing, sir. Sir, now I'll check again, cross check once again. That only that folder I will send it in the WhatsApp. Okay?
Yes,
That time
ma'am.
will try out. Okay? I think by opening this folder, it should open whatever I sent now, the same I connected here. Okay? You check once again. All of you, please check once again. That's why I'm telling. Now only you have to check the fluid sim. After going, if it is not working, means I cannot think. You will just see. This is a demo version which I shared. Okay. We'll go back. You go back to your folders. I will just show the path where to go. Go back to the folder. Close it. Close everything. Close it. Go back. Please see here. You got actuators. Actuator folder you got. All of you first actuator folder. In your drive, you open actuators folder you got.
Can you please respond?
All of you please respond. All of you got actuators folder.
Yes, ma'am. Yes, ma'am.
Then after that, you got that safety symbol, wall and field bus.
Yes, ma'am.
Then the folder will be having FSH3, demo 3, demo.
Yes, ma'am.
Then FSP3 demo. All of you got this. Please check 3.
Yes, ma'am.
Then you open that only. You open, it will be working, ma. No, see, I will show you. Go to this FSP3 demo. Double click. Go to bin. That is bin. Then go to again FSP demo. Festo. Festo, its name is given Festo. Double click on this. Up to here, if you go means it will be you are getting.
Actually, it is not showing, ma'am.
Not showing. Okay, no problem. Maybe it is something which is problem. I will send once again today. After going to send that original CD with searching.
Ma'am, can you again tell the path from Ongc online Hyderabad to NAC? Ma'am, there are
I'll send you the path, ma'am. I'll definitely send you the path. Okay.
Ma'am, what you're talking about, this Festo is not showing in this folder.
Festo is not showing in the folder.
It is showing FSP demo, but it is not showing the symbol which was there.
Okay. Here I am showing the 3, but it is come here 3.5. I think something is problem. Okay, no problem. Don't worry. I will go back and I will check once again.
Ma'am, there are so many folders in this.
There are 2 folders with a flash demo.
Okay.
Yes.
So we have to go to the second one. FSP3 demo, there are 2 folders. We have to go to the second one. There we will find the same which you have shared on the screen.
Okay, that first one you delete it. By mistake it has come, I think, some error. The first one is delete. Whichever is working, you keep it. All of you.
And the second one is working.
Okay. A simple one single acting cylinder with 3/2, one double acting cylinder 5/2 or 4/2. You work it. If you get any doubt, you please come back. and we'll solve that things. But this software is very useful for you. Before going to the trainer kit, if you do and here, you'll get more confidently. You can work on the see here trainer kit. Nothing will happen, but your working pressure will be high in the your working area. That time you have to simulate, and you confidently you can go and check it. This software is very, very useful for you. Okay. Then today I will try for the more versions. 3, then 3, 4 is there. 5 version is a license version. 4 I will also try. I will work out and I will send you the path. Okay. Yeah, all of you okay? All of you please check. Or those who got no, please share to your friends so that they can also first let it be working condition. After that, you do the exercise, not do the exercise is secondary. But all of you should get that software.
Ma'am, why can't you send this folder to our email IDs, Ongc mail IDs?
Okay, ma. Okay, ma.
All your mail IDs on WhatsApp will do it.
No. I have your mail IDs in the with this whatever it is we are having in this one, na. Your list is come out, na. In that your numbers and email IDs are given. Correct? And Animesh, our Pandeji, yes, Sai Kumar, Singh Tiwari. Correct, na?
Yes, ma'am.
So ongc.co.in. Correct, na?
Yes, ma'am. Yes, ma'am.
Send you to this, ma. Only the other things you got, I think.
No,
Okay.
everything we received, but the thing is like it is not getting downloaded in our PCs. I don't know why it is so.
Maybe something problem with fluid sim thing.
In Drive, I think there is a problem.
Okay, ma. Okay. Now I will go home. I'll check again. Once again, I will send it with the emails. But what is the problem means? Mail means the folder should not be with more MBs, na. So I planned like this. Okay. Okay, no problem. Okay, no problem. Now I'll come back here. Without see, for one more thing, what we have to do is we have to work. After that, the supporting folders may be corrupted. That is also maybe problem. I will check with the drive and this fluid sims, and I'll come back to you. And some more material I have to add today. That I will check everything with the drive. Okay, is it clear?
Okay, ma'am.
All of you, I think, no doubts. Okay, shall we end the session?
Yes, ma'am.
Yes,
I
ma'am.
think today we had no disturbance in the other end also. Is it clear? Audio, video, any disturbance for anything? Anyone?
No
No,
disturbances, nothing, ma'am.
Okay, clear. Okay. Okay, today's session I will close here. Tomorrow you please come with your whatever the doubts and like this, whatever the downloading or material something. I'll come back to you with the new material and new software. Okay. I'll send it in the mail. That only that fluid sim, I'll send it in the mail, ma. Okay. Clear?
Thank you so much.
Okay, ma. Okay, ma. Bye. Okay.
Bye.
Good evening. Bye.